Welcome to Slew Space Camera's live coverage of the total lunar eclipse, sponsored by Transformers, Dark of the Moon, the new Michael Bay film in cinemas from June 29th. The only way to see it is in 3D. Slew's live audio coverage of the total lunar eclipse is hosted by astronomer Bob Berman and powered by WSRadio.com, the worldwide leader in Internet talk.
Hi, this is Bob Berman, and great to hear you. And this is a fabulous occasion that we have here, a total lunar eclipse of the moon that's going to begin in just a few minutes from now. And we're going to be looking at the moon, all sorts of aspects of the moon live. We've got tech people standing by in strange parts of the world. Well, to us anyway, Cyprus, Dubai, South Africa, and they are, even at this moment, as you can see, transmitting the image so far of the perfectly full moon, just about to go into Earth's strange red shadow. And during the next hour, we're going to talk about what makes eclipses so special, some of the oddities of the moon and the full moon, the lore, legend, the science, the mythology, all sorts of things to do with the moon. And then, about an hour from now, we're going to have our first guest, who is Dr. Duncan Kopp, an astronomer in Britain. He's standing by in the London area. And then after that, we're going to have a British woman astronomer as well on. So we're going to have a lot of fun during the next 4 hours of live eclipse. So grab yourself a sandwich, whatever you need to keep yourself going for the next 4 hours while we explore this exciting event. We want to thank Slew for this, Slew, the space camera, which is really putting this together, and of course thanks to Google and Noel Gorlick, especially at Google, who's really the guy, the champion at Google, who's put this together, and of course Paramount and for sponsoring it. So here we go. I'm Bob Berman, normally the astronomy editor at the Old Farmer's Almanac. That's the original one, the one with all that yellow writing on it, and Astronomy magazine. But I'm not here to talk about myself. We're here to talk about the moon. Take a look at that. Isn't that cool? There's the full moon, looking not very different from the way you'll see it tonight when you look up. Nice thing about the moon is, number one, everybody can identify it. You don't need to know any astronomy. I think every child in the world, every old person, every mental patient, if you point up to the sky and say, "What's that?" they'll say, "Why, that's the moon, of course." But point to just one more object in the night sky, and most people can't figure out what's going on. So that's the first attraction, of course, that eclipses involving the moon or the sun require no knowledge at all, and yet they're very cool. It's a lineup. The word for the lineup is syzygy. Some people say that's a great Scrabble word, syzygy, because it has all those G's and Y's and Z's in it. How many words have more than one Z? But probably not very good for Scrabble, because there's only one Z, so you'd have to use a blank, and never mind, not worth it. Syzygy is a lineup, a straight line in space of any three astronomical objects, and that's what's just about to happen. We're going to have the sun and the Earth and the moon in a perfectly straight line. It's already almost there. If you could be on the moon right now, you'd see a sun looking about the same size as the sun looks from here. Then you'd see the Earth, just the night side of Earth, looking totally inky black. And the Earth looks 4 times the size of the sun, or for that matter, 4 times the size that the full moon looks from here. And it would be just now, at this moment, on the edge of the sun. So the two of them are together. And as we look at this live view, you can already see that there's a slight trace of a bit of darkness on the left. That's called the penumbral eclipse. It's not the real dark eclipse yet, the shadow line. That's going to start in only about 15 minutes from now. It's the penumbral eclipse, and that's the side of the moon we want to keep an eye on. That's where things are going to change. So right now we're still looking at a full moon, the full moon of June. And maybe we should talk about that, the full moon of June, because it's the moon that's the lowest in the sky for those of us in the northern hemisphere. the moon closest to the solstice. And before the eclipse begins, we still have that, the glories, the strangeness of a full moon, the most famous phase, and the phase of the moon most associated with crazy stuff, ideas of mental illness, and let's see if any of that stuff happens. We're going to watch ourselves here on the show and our guests and see if there's any sign of odd lunar behavior during the next few hours while the eclipse takes place. The exact middle of the eclipse always corresponds to the precise moment of full moon. And middle of the eclipse is going to happen at 20 hours universal time, which if you know how many hours to subtract from wherever you are in the world, you can figure out what time that would be for you. That would be about 12 minutes after 4 o'clock here in the Eastern Daylight Time Zone. So wherever you are, it's coming up now. They have all sorts of names. If you watch TV, they'll say it's the full moon, and therefore the real name for the moon is the rose moon, the full moon of June. But although the colonial Americans called it the rose moon, they also called it the stockman's moon, the strawberry moon, the hot moon, the flower moon, and even the honey moon. That's kind of cool because honeymoon, of course, has that other meaning. I wonder if that's because the full moon of June, this full moon right now, is the lowest in the sky of the entire year. And therefore we're seeing it through more thick air near the horizon. So it really is amber or honey-colored. It's an appropriate name. So when the colonials called this June moon the honey moon, it's not that crazy. The Algonquin Indians called it the strawberry moon. The Lakota Sioux, the moon of making fat. I'm just looking at this. Don't think for one moment that I've memorized this stuff. This is just a list of the Native Americans, and all sorts of. Some of them are a little strange. For example, the Wisham Indians called it the rotten moon. So we're looking at a rotten moon. Okay, so let's all enjoy it. We'll enjoy the rotten moon for the next 4 hours as we watch our live coverage from various parts of the world. And there's some clouds I can see moving in front of the moon through one of our sites. That's the thing about live astronomy. You just never know what's going to happen. And as we do that, I just don't want you to think that what we're seeing is the actual blotches that are happening on the moon. That would be sort of an alien kind of invasion event. That would be something to sound the alarms and tell your friends and call the police. And I always wondered about those movies, by the way, when the aliens come and everybody runs through the streets screaming. Where are they going? Where would anybody want to go if aliens from another world are coming? It would seem that no place would be any better than any other, right? I guess you'd want to get away from cities. But that's not what people do anyway when they're scared by some national event. I think what really happens is that people want to be the first to pick up the phone and tell your friends. Be the first to tell your friends. That's what we really do. Anyway, the San Juan Indians called this the leaf dark moon. The Oto Indians, the hoeing corn moon. The Laguna, the corn moon. I guess because corn was starting to grow at this time of year. A lot of them called it the strawberry moon, like the Algonquins and the Kootenai Indians called it the strawberry moon. And my only point to all this is that whenever you hear on TV that here's the full moon and it's the rose moon, well, it isn't. The only official names for any full moons, there's only two of them, and that is the moon that's closest to the equinox in September, to the autumn equinox. Well, that's the harvest moon. That's an official name. And the next full moon after that is the hunter's moon. Those are the only two official full moons. So we're looking at a full moon now, the full moon of June, that had all sorts of names going out in history, but none of them, not one of them, that are really official names. As we watch this full moon and fighting a little bit of clouds here, we're going to look at some of the features on the moon because I think that's really cool just before the moon gets covered up. Look on that right side of the moon, the upper right. And if you're on SLU, there's a lot of different places to watch this. I'm over here at eclipse.slooh.com. Slooh is always S-O-O-H. So if you're not seeing a Slooh image, if you're not seeing an image of the moon at all, go to eclipse.slooh.com, and then you'll be propelled to the Slooh world. Slooh is a series of telescopes around the world that are automated, some proprietary, amazing technology that lets members click a button on their own computer and make the telescope point wherever they want in the whole world, the whole universe. For example, a few weeks ago, less than 2 weeks ago, suddenly a star exploded in the Whirlpool galaxy. And people at Slooh did not have to wait to hear any official announcements by the world's astronomers. They saw it happen. Boom! Star exploded. It's still there tonight. In fact, we don't even know what it's going to look like from night to night because supernovae can do odd things. So you might want to consider becoming a member. I think I've heard that they have some kind of special deal. Click on Slooh and join it. Take pictures, look at the universe live, and that's what Slooh is doing now. It's really Slooh that we have to thank for this live lunar eclipse event. Normally, the Slooh telescopes are set up at these big observatories in the Canary Islands and Chile, but to get the best view of this eclipse, they've actually sent some of the Slooh tech people to these other parts of the world where the moon is still up nice and high in the sky, and where it's happening. So look at the right side of the moon, about the 2 o'clock position. I'm assuming you can see the moon here live as we are doing. We're only a few minutes now from the beginning of the actual umbral eclipse, when the moon's going to be visibly changing before our eyes. So we're actually watching the last of the bright full moon now. And on the right side, sort of the 2 o'clock position, if the middle of the moon were the middle of a clock, you'll see a small, almost perfectly round, dark blotch. All those blotches on the moon's face are Maria, and which are, I've also heard it pronounced Maria. I prefer it myself, Maria. That's the plural of mare, which in Latin means seas, because the early observers thought they were looking at oceans on the moon. What did they know? Even with the telescope, you can't tell that these are not giant bodies of water. That's what they thought we were looking at. Kind of reasonable. You know, even when we look at Earth from space, the dark blotches are essentially bodies of water, although Earth has color and the moon does not. These are true color images, by the way, that we're seeing. And you kind of waste a color camera, or in the old days, color film, on the moon because it's the grayest object in the known universe. In fact, it gives us a little bit of a clue as to what it's made of. When you think of objects that are common and can't be too valuable, because if the moon had valuable stuff on it, you know we'd be going back there, which we're not. So why is the moon gray? Think about common things that you see in life that would have to be cheap and that are kind of whitish. What is that? What do you think the moon is made of? What would be your guess? Well, the answer is sand. The moon is covered with silicon dioxide, like quartz, like pieces of quartz. Doesn't it kind of look like it's quartz colored, except here on the moon, bombardment for billions of years by tiny meteoroids have acted like little hammers and have been grinding the moon's surface down until now it's the same consistency as baby powder, talcum powder. It's very fine, very pleasant to the touch. Although, when the first astronauts on the moon, famous date, of course, July 20th, 1969, and our first guest, Dr. Duncan Kopp, who's coming on later, has made a number of fabulous documentaries about the moon landings. I've written a book about the moon landings as well, and I can tell you that when they first went to the moon, all sorts of strange things happened that you don't hear on TV. We're going to talk about that a little bit later, the odd astronaut stories that you don't often hear. But going to the moon surface we've now found that it's very fine baby powder. And as they were transferring it, the first astronauts, Armstrong and Aldrin, and they went back up to the command module that Michael Collins was commanding and transferring all their bags of moon dust, which had a lot of loose dust on it. Collins said that some of the dust which got into the air, and everybody was breathing it a bit and sniffing it, he said it smelled awful, that the moon stinks, that the surface actually smells horrible. Now, you wouldn't think something made of sand would have a bad smell to it. So what we think, we're just guessing here, that since about 12% of the moon's surface is covered with iron oxide, actually, it's not even so much iron oxide as various iron compounds, that since iron does have a smell to it, it's probably that. Sometimes the minor components of a substance are what give it its smell. In any case, that's a revelation, right, that the moon smells bad. Although maybe Michael Collins was just getting a whiff of Buzz Aldrin's socks as he was getting back into the command module. Who knows? But as we now know, that very fine baby powder surface of the moon has been pounded for so many, not millions, but billions of years, until now it's covered with this quartz that's been pounded down to just a little powder. And that's what we're seeing on the moon now. So inexpensive stuff. Now
Bob,
we're getting ready for the start of the eclipse.
Can you hear me, Bob?
And that's going to be coming up in just about 5 minutes. Now, already you'll notice that the left side of the moon is dark. I want to tell you what's going on there. If you were standing on the left side of the moon, you'd be seeing part of the sun blocked by part of the Earth, which means that some sunlight is still hitting that left area. What we're waiting for is the shadow where all of the sun is blocked out by a piece of the Earth. And that's going to happen. Again, the Earth is 4 times the size of the sun as seen from the moon. We all know that in reality, the sun is much bigger than Earth. But from the moon, Earth is so close, only 250,000 miles, whereas the sun is 93 million miles away. So the Earth appears much larger. That's going to also explain why the edge of the shadow that we're going to see has a kind of an odd property to it as it starts intruding on the moon's left side or eastern side. We're seeing the moon here through the SLU space cameras. I don't even like that word camera, because camera suggests that it's an already taken picture, it's an old image. We're seeing it live. The SLU, again, SLOOH, is our live telescopes. Camera is not a terrible way to call it, because SLU members can just click on a button and take a picture and then have it on their computers or send it to people. So in that sense, it's a camera. But the images are always live. So we're looking at live shots of the moon, and we're only now about 3 minutes from the umbral start of this total eclipse. It's an unusual eclipse in that the moon is going to go centrally into Earth's shadow. That hasn't happened for over a decade, and it's not going to happen again for almost another decade. Because the moon can hit our shadow near the top of it, near the bottom. In fact, it can half miss it so that we get only a partial eclipse of the moon. This time it's going to be penetrating it centrally and fully and right through the middle of it. It's also going to produce some odd effects. A lunar eclipse is the only celestial event in which we are told about ourselves. This is going to give a report card about Earth's environmental health, at least our atmosphere's health, because Earth casts a odd red shadow into space. You and I cast a black shadow behind us when we walk on a sunny day, but Earth casts a red shadow. But that color changes from time to time. Sometimes it is closer to black, sometimes it's barely there at all, and sometimes it has a deep coppery look, sometimes it's lighter copper, and the color of the shadow really gives us an environmental report card about our own conditions. Since we've had an eruption down in Chile very recently that has thrown up a lot of dust into the stratosphere high up. We're thinking that maybe when the moon is fully in the eclipse, and we still have a ways to go before that, middle of the eclipse is almost 2 hours from now, then we'll see an irregularity on the moon, where the bottom part of the moon is perhaps closer to that black appearance and the top is more red. That would kind of make sense, but nobody knows. That's one of the fun things about total lunar eclipses. You don't really know what's going to happen. All right, now we're only 2 minutes from totality. Did I say totality? I mean the partial umbral eclipse. We were just talking about totality. Totality is actually going to be when the moon is fully in the eclipse. That's going to happen in exactly an hour from now. But we have 1 hour's worth of moon travel as the moon goes into Earth's shadow. And that's the beginning of the umbral eclipse that comes up in just 1 minute from now. The reason you're already seeing a darkness on the left side of the moon is because if you were standing there on the left side, you'd be seeing the sun almost completely blocked by Earth.
I can hear one.
As you stand further and further toward the right side of the moon, you see the sun either unblocked at all, that's on the right side of the moon right now, or let's say on the middle of the moon, slightly blocked, where just a tiny bit of the sun is being obstructed. So essentially all of the sunlight is still shining down on the middle of the moon. So there's a slow gradation in brightness from one side to the other on the moon. But the part where it's completely blocked, where it's fully covered and no sunlight at all is hitting it, that's the part that is going to begin in approximately half a minute from now. Now, you'd think that would turn completely black. Let's see for ourselves whether the moon goes perfectly black when it loses the last vestiges of sunlight or not. It's the fun thing about a live event here, presented by SLU. We, of course, want to thank Google, too, for doing this, and our sponsor, Paramount, for making this possible. Not easy sending people to all these parts of the world to transmit this. Also, the guests that we're going to have. We're going to have Dr. Lucy Green from Britain coming in about 2 hours. We're going to have, in much less than that, closer to 45 minutes from now, we'll have another astronomer, wonderful astronomer, Duncan Kopp. And so we'll look forward to seeing him, too. I'm Bob Berman, normally with Astronomy Magazine and the Old Farmer's Almanac, among other things. And here we go. We are now starting the full eclipse, called the umbral eclipse, or called the partial eclipse. That's scheduled to begin in about 15 seconds from now. On the east side of the moon, the left side of the moon, that's going to be the area that is fully eclipsed. We're going to look for colors, especially as the eclipse progresses, and other strange features. And during the next hour, we will also talk about what the moon does to us. Mental illness, crime, births. Does it affect human births? We'll talk about the people who have been to the moon, plans to return to the moon, why it's maybe a good idea to do that, and maybe why it's not a good idea to do that. And all sorts of aspects, oddities of the moon. Everything you always wanted to know about the moon, but here it'll come, because we have a total of 4 hours of coverage. We have another 3.5 to go. And there it is. The eclipse is now officially underway. We've been watching the penumbral eclipse up till now, but now we start with the actual full umbral eclipse. So, to repeat, if you were on the left side of the moon, just right on the left edge right now, you'd be seeing the black part of Earth. Absolutely inky black, the night side of Earth, which will include North America, Canada, the United States. From the moon's perspective, we're the dark side of the Earth right now. The part that can't be seen, we're going to be rotating into that very shortly. the part of the Earth that is facing the moon, that is the absolutely darkest side. The night side is the side centered in India, and that's why people in that part of the world can see it. Right now in the sky, if you have it on your computer, you can also just step outside, look up, and there's the same moon that the rest of us have to see on the computer. Because if you have the moon in your sky, if it is nighttime right now, then the eclipse is underway. The moon continues to go into our shadow, moving at 2,287 miles per hour. Interestingly enough, the moon is, and I hope you don't mind miles. We're here in the United States right now, and we're still used to miles, so I'm going to give everything in miles, and if you prefer kilometers, well, you know what to do. Just multiply it by about 1.5 to get to that, a little bit more than 1.5. The moon is 2,160 miles in diameter, and it moves through space in its orbit around Earth, 2,237 miles per hour. So that's very similar, those two numbers. Isn't that? It's fantastic that the moon's size and its speed are almost the same number. 2160 on the diameter, 2287 on the speed through space. 2,287 miles per hour moves through space, and that means that the moon moves its own diameter each hour. You know what other object in the universe moves its own width per hour? None. The moon is the only known object that moves its own width per hour. And we're going to see that happen. We are seeing that happen as it moves through space. It means it's going to take an hour for the moon to first contact Earth's shadow, and it's going to take 1 hour from that first contact to the time when the moon is fully within the shadow. And if you're using universal time, the eclipse started at 1822 minutes, 18 hours, 22 minutes. Totality begins at 1900 hours and 22 minutes, exactly an hour. So isn't it wonderful when things make sense? Great, isn't it? So now we can see the curvature of Earth's shadow. This is so cool, isn't it? And there's no question that Earth is round. You remember when we learned in school that Columbus was pretty much alone when he said that we live on a round Earth and all the others thought it was flat and all the rest of it? That really wasn't true, because even the ancient Greeks, people like Eratosthenes, knew that Earth was round. And there's two ways that any of us can prove to ourselves that we live on a spherical planet. One is if you stand near the ocean and you see ships approach from a distance, you first see the tops of their masts, and then as they get closer and closer, you see more and more of it. So obviously they're over some kind of curve. But secondly, lunar eclipses like the one we're seeing now, and which occur almost every year, only occur when the moon goes into the spot exactly opposite the sun in the sky. The ancients knew this, the Greeks knew this, the Egyptians knew this. Only when the moon ventures, I'll repeat it, ventures into the spot of sky opposite the sun does it go into eclipse. Now, the spot opposite the sun must be where Earth casts its shadow, because shadows are always cast opposite the sun. So it was obvious to all thinkers thousands of years ago that the moon must be venturing into Earth's shadow. So all you had to do was look at the shape of the shadow, and you could figure out the shape of Earth. And there it is. We can already see this early on in the eclipse that Earth has cast a round shadow. The only argument might be, but what if it's just a dinner plate? What if Earth is a disk? It's not a sphere, not a globe. It could be a disk, couldn't it? Then a disk would cast a round shadow. But that doesn't really work, because a disk only casts a round shadow when it's perfectly perpendicular to the light source, right? And most of the time the geometry would be such that the disk might be edgewise to the sun, in which case it would be a straight line that would be cast on the moon. Or else it could be anything in between, in which case you'd get a sort of ellipse cast onto the moon. But when the moon goes into Earth's shadow, the thing that blocks it out is always round, and only a ball always casts a round shadow. So here was a proof to people like Aristarchus and Eratosthenes and the ancient Greeks that Earth must be round. There it is. We're looking at it right now. So if you have any flat Earth friends, call them up right now. Get them onto this site. Again, it's eclipse.slooh.com, and say, there it is. It's too bad we can't convince some of our friends who think the Apollo landings on the moon were all a government conspiracy. Too bad we can't convince them as readily. Those of us who have actually known some of the people who worked on the Apollo program, 500,000 people worked on it, by the way, during the 60s, or spend time with any of the astronauts who went there, there's no question about it. What? Are you telling me that you're one of those who wonder whether we went to the moon? Well, here's a quick way of knowing. 3 of the Apollo teams left behind corner cubes on the moon. A corner cube is an object like one of those highway signs that always reflects light right back to its source. When you're driving down the highway, you know how those signs become very bright as your headlight hits it. Corner cube is even more accurate, though. The mirrors in it are set up at right angles so that they'll always send light precisely back toward their source. And since they were left at 3 different places on the moon, anyone, any university, and we still do that, any facility that wants to bounce a laser to the moon, send a laser pulse, and then wait for the pulse to return, which it does in about 3 seconds, can prove that there are corner cubes there. And how did they get there? So, and by the way, these corner cubes show us that the moon is changing its distance because we can time the pulses. We know the speed of light, about 300,000 kilometers per second, or if you want to be exact, 186,282.4 miles per second. Well, since we know the speed of light, we just time the pulse from the time we send it to the time we receive it, and we can figure out the moon's distance to a matter of an inch or 2. In doing so, we've discovered the moon is going bye-bye. The moon is leaving us. It's spiraling away from us at the rate of about 1.5 inches a year. That means the future is not going to be this bright as so far as eclipses go. Although maybe that's a bad analogy to speak of eclipses as having a bright future. In other words, it's not going to be as dark, because as the moon spirals away from us and also slows in its orbit, what's happening is there's a transfer of energy. The moon and the earth are bound. They have angular momentum in common, and some of the energy is being transferred to the moon, and it's also acting to slow down the earth. The earth slows down by about 1/700th of a second per century. After each century, the day is 1/700th of a second longer. A lot of people think that's why we have to meddle with the clocks from time to time and add leap seconds to many of the years. But it really isn't. 1/700th of a second per century is not enough to make us add leap seconds. We add leap seconds because the day that we established was wrong. We established the length of the day based on kind of the way the day was in the middle of the 19th century. And because we have a wrong average day, that's why we have to keep adding leap seconds. Nonetheless, Earth is slowly slowing down. At the same time, the moon is spiraling away from us. So it's something like 70 million years. Eclipses are going to stop happening. We won't have them anymore. Solar eclipses, at least, those are the first to go, the total solar eclipses. The moon has a longer life with eclipses because Earth's shadow, you could see the shadow now eating up more and more of the moon. The Earth shadow spreads into space about 1 million miles. Tapers all the while. Tapers like a chopstick as it goes farther and farther into space. It starts off, of course, the size of Earth, roughly 8,000 miles in diameter, 4 times the size of the moon. or if you want to be exact, 7,926 miles in diameter. As it goes, it tapers off, so by the time it gets to the moon, it has lost a little bit of that, but it's still twice the size of the moon. And you can see that right before your eyes, that the arc of Earth's shadow is obviously the section of a larger circle than the arc of the moon. Look at the moon's limb in space against that blackness of space. Look at the size of the moon. And now compare that to what the size of Earth's shadow must be. And you can see that Earth's shadow is obviously larger than the size of the moon. So moon is going into a shadow that's much larger than itself, and we're watching it continue to penetrate. The shadow continues on for about 1 million miles until it comes to a little spot and disappears. So since the moon is only a quarter of a million miles from us, it still has a ways to go before it no longer can penetrate our shadow. So we're going to have lunar eclipses for a lot longer in time than we're going to have total solar eclipses. Those are much more critical. Later on, we're going to talk about upcoming lunar and solar eclipses, especially when this one is starting to near its end, because total solar eclipses are, to be honest with you, those are the ones that make people weep. Those are the ones where the animals go crazy and they act up and strange behavior. When nuclear flames come out of the edge of the sun visibly, and streetlights come on, and the stars come out in the sky, and strange things are happening. So if you can, definitely get to a total solar eclipse. Those are kind of rare. They only happen once a year, roughly, not even every year, somewhere on the Earth. And for any given place on Earth, if you're a stay-at-homer, if you don't want to travel, well, that's a little rougher because they only happen once every 360 or 370 years for any given spot on Earth. And if it's cloudy, you have to wait another 360 years. So they're kind of rare. So we're going to talk about total eclipses of the sun that are coming up in the next few years, and we'll also talk about the next eclipses of the moon. They're not that common. You don't get a lot of shots at them. So we're enjoying this one here tonight as the moon continues to chug along into the eclipse. Coming up in only about 20 minutes, we're going to have our first guest of the night, and I'm really looking forward to it. This is going to be Duncan Kopp. I'll tell you a little bit about him now, and I'll tell you a little bit more just before he comes on. I should say Dr. Kopp, but hey, I'm going to be informal with this, since he does have both a master's and a PhD, both from the University of London. Doctorate in astronomy, and his master's was in satellite remote sensing, and as I understand it, his doctorate, what he mostly did was studying volcanoes and geologic processes on Venus, our nearest neighbor. And he was a member of NASA's Venus mapping team, and they created the first detailed geological maps of the planet. But he also knows a lot about the moon. We're having him on for, among other reasons, is that Duncan conceived and developed and produced a very acclaimed feature documentary called In the Shadow of the Moon, which I just saw a few days ago, and it was really great. Since I wrote a book about the moon some years back, you'd think I'd be absolutely sick of the whole astronaut business, but this was a fun movie. I really enjoyed it a lot. And apparently a lot of other people did too, because it received over a dozen international awards. It won Best International Film at the 2007 Sundance Film Festival. So, In the Shadow of the Moon. That was produced by Duncan Kopp. We're going to have him on in only about 20 minutes from now. Meantime, we're seeing the moon continue to chug into Earth's shadow. Boy, it's so crystal clear now what Earth's shadow looks like. Now, here's something very cool that amateur astronomers have always noticed, and I want to point this out here, is that when the moon first goes into Earth's shadow, like now, the shadow looks black, doesn't it? And either when you're watching it on the computer monitor, as you are right now, or actually if you're listening to this, since this is being sent all over the world by SLU and by Google, if you're in one of the parts of the world that are on the night side of Earth right now, and we're talking about places like the Middle East, or especially Asia, as you look at it directly in the night sky or on a computer monitor, you'll see that the shadow looks black. But when the moon's almost fully into Earth's shadow, that shadow is going to start looking red, coppery red. Although you never know for sure. As I said, that's one of the surprises of total lunar eclipses, is that the shadow changes its appearance from eclipse to eclipse. It tells us about how clean our air is. If our air is normal, that shadow, starting at around the time that the eclipse is almost total and continuing through totality, all of totality, the moon should look coppery red. That's normal. Then you can breathe a sigh of relief and know that Earth is okay. This is not 2012. The Earth is not ending. We're okay. If the eclipse stays black, which happens once in a while, that means there's a lot of dust or pollution in the air. Could be Chinese factories, but more likely it's due to the great volcano that just erupted in Chile. It sent a lot of dust skyward. Of course, there's been volcanoes in Iceland as well. So we can look at the part of Earth's shadow that's darker than the rest, and we can tell which volcanoes are responsible for the discoloration or the mottled appearance. That's going to be so cool and so much fun to do. We're going to be able to assess that in only about half an hour from now as the moon continues to go in. But we're expecting the shadow to turn red. If it's red, if Earth's shadow is red, why does it look black now? Two reasons. One, if you're looking at it directly, your eye is setting the light levels, that is, your pupil is dilating, and plus whatever photochemical reactions are occurring on your retina to set the correct exposure for the moon. And most of the scene involves the bright moon, and therefore you're going to underexpose, your eye will underexpose the eclipse part of the moon. Here, looking at it at a monitor, the same thing happens. We are showing you the moon with a correct exposure to get the entire image, and since most of the image is the bright moon, magnitude minus 12.6, it's the full moon, pretty darn bright, certainly is bright enough to subdue all the background stars. It means that we are going to have to underexpose the eclipsed part of the moon to bring you a correct exposure of the whole scene, including the part that's not eclipsed. However, when the moon has been reduced to just a small sliver that's uneclipsed, by then we will start to set the exposure more for the whole image, including the now dominant eclipsed portion of the moon, and then we'll be able to properly assess the color. So the true color is yet to come. We're going to be seeing that not too far in the future now. You're watching the live lunar eclipse coverage brought to you by Google and SLU, the SLU space camera, SLOOH. We're seeing it happen directly in front of us. I'm Bob Berman, your host for this, the entire 4 hours, and glad to be here today. Am I allowed to slip in a plug? I guess so. My new book coming out next month is The Sun's Heartbeat. Publisher is Little Brown. There, I did a plug. Was that shameless? Maybe. Did it anyway. Sun's Heartbeat. Anyway, I'm glad to be here. Let's talk a little bit more about what the moon can do to us, in terms of affecting mental illness, crime, those kind of things. We've all heard things like that. I've heard teachers say that, full moon, this is the time when the kids are all acting up. People at hospitals think that there's more births. That's so prevalent that some years ago when I wrote an article about it for Discover magazine, I actually talked to a lot of people in the maternity wings of hospitals, and they all believe it. They think births increase at the time of the full moon, like now. It's the night of the full moon. Are there more births? They think so. In fact, one woman said, I've been in this maternity wing for 20 years. Of course there's more births around now. Ask anybody. And she's right, in a way, because everybody really believes it. But when actual studies have been done, all sorts of studies in France involving 6 million births, one in New York City involving 500,000, and then another one, this was in the late 50s, Menaker and Menaker. I even remember the name of the research team. It was a father and son set of doctors. And they found in New York City 2 separate studies, 500,000 births each in public hospitals in New York City. So in other words, they had about 1 million people combined. That's a good-sized study. They found a 1% increase in births. In the first study, it was around the time of the full moon, but in the follow-up study, it was the time of the first quarter moon, not the full moon. So the studies kind of contradicted each other. Taken together, they would indicate a 1% boost in births during the bright half of the lunar month, centered on the time right now when the moon is full. But other studies done in other countries and other cities found no results. And some years ago, the magazine Psychology Today did a meta-study combining all of the results, and they said, nope, no such thing. Births are random around the lunar month. So the question becomes, why do we see these effects? Why do people think that kids act up around full moon and births increase and crime increases and mental illness increases? Truth, studies of admissions to mental hospitals and calls to crisis centers and things like that show no greater increase at around the time of the full moon. So why do people see these effects if they're not real? And the general consensus is that the moon is so bright. Did you know that it's 450,000 times brighter than the sun? Yeah. Most people would guess, I think, if you ask people, how much brighter is the sun than the full moon? People would say maybe 200 times, 500 times. No, it's 450,000 times brighter. And but at night, it so dominates that people notice it. And since ancient times, people have associated the full moon with things happening on Earth. So if you happen to get a weekend when there's a lot of births, all the doctors and the nurses on their way to the hospital, they've noticed a full moon, they see a lot of births, and they make the connection. But on another weekend when there's not a lot of births, at the full moon, they don't even think about it. They just don't make any connection one way or the other. So over time, we get these connections between the moon and all sorts of things, which are spurious, not true. They're false. And that's not to mean that the moon has no influence over us. Obviously, it greatly affects the rise and fall of the seas. There's a 3-foot, or about 1 meter, pulse to the oceans every day, worldwide. And a lot of sea life, especially in the intertidal zones, the endless marshes and saltwater areas like where crabs and other creatures depend on the tides, their lives have become attuned to it, and the predators that have fed on them. And so there's a lot of creatures in the world that are aware of the lunar phases because of the tides. And there's another thing, too. That full moon that we're seeing is so bright. You know how they say people feel romantic when the moon is full? So it may have been the only nocturnal condition in which our ancestors felt safe enough to pay house calls, cave calls on the opposite sex. You know, if you ventured out in the dark of the moon, in the olden days, there were predators out there that had bigger eyes and faster legs. They were more powerful. You know, your date could end early when you or your boyfriend were eaten. Now, that wouldn't have been a good way to end the date. So it could have been that humans started venturing out more at the time when the full moon was out, when the moon was bright. And over time, we could have become attuned to that. Our fertility could have become attuned to that. Needless to say, people have always noticed, why is the human estrous cycle, cycle of women's menstrual cycle, so close to that of the full moon? The cycle from full moon to the next full moon is 29 and a half days. 29 and a half days. And recent studies have shown that that's almost exactly what the human estrous cycle is. On the other hand, if you want to argue it the other way, there's only one other animal with the same cycle, and that's the opossum. So we'd have to believe that only humans and opossums have been chosen for this dubious link with the moon, and that the entire rest of the animal kingdom has been exempt from having any estrous cycle that matches that of the moon. So I guess you could argue, both ways. But in any case, these days, the full moon sadly gets kind of not noticed. We live in an era of artificial lights, which has made moonlight superfluous. We don't need moonlight anymore to go out on dates. And so you'd think that has changed. The way we carry on, it has not. It's also one more thing. The full moon has a slight correlation that we've discovered in the last 30 years between weather and the phase of the moon. In other words, there's increased rainfall, cloudy weather, just a bit more at the time that the moon is full than at other times. And since cloudiness really is linked with a change in mood, here at last is a actual mechanism, even though it's very subtle, by which maybe the moon can influence our emotions, at least statistically. But there's a feeling. I mean, who of us can deny that there's a feeling to moonlight? Especially those of us who live out in the country when the moon still bathes the rural roads if there's no street lights. It has a feeling to it. This is not scientific to say that, but people have memories too. Instinctive feelings that have probably been summoned up for centuries about the feeling of the moon. So without even invoking ancestral imprints and genetic memories and things like that, most of us do have conscious or subconscious childhood recollections of moonlit nights, and we probably carry those sensations throughout our lives. So as we now look at the live coverage of the full moon, almost halfway into Earth's shadow right now, most of us would probably agree that there's a sort of unscientific or unnamed impression that the moon gives us, and that we're experiencing right now. So the moon's mythical link with romance and courtship, and not to mention that it pervades poetry and literature. And so we have it in our kind of a collective mindset in this direction. And because of that, just because we expect it to influence us romantically and poetically, just because of all that's been written about it, it probably has an actual effect on our moods and emotions just from belief and expectation. So some of the moon's alleged powers that you keep hearing about, influence, may actually be valid without even needing to be true. This is the SLU and Google coverage of the live lunar eclipse. It's in the sky on those who are having the night side of Earth right now, and the moon is not in the sky for those of us in, let's say, North America. So that's why we are having this great coverage. We have telescopes that have been set up. The normal SLU telescopes are in the Canary Islands and Chile. Those are the big telescopes. We've sent teams of people to bring you this coverage from other places. If you are on eclipse.slu, SLOOH.com, you're seeing it right in front of you now. South Africa, Dubai, Cyprus, and we're watching the moon go chug into the shadow of Earth. During hour 2 of this coverage, we're going to bring along a very honored guest here, and that is Duncan Kopp. He's going to come on in just a few minutes. We're going to have a station break in a few minutes, and then after that, I'm going to introduce him a little bit more. It's going to be a lot of fun. Fun guy. Talked with him the other day, and he also has, I think, a lot of stories to tell about the astronauts. When I was doing research for my own book, it was fun to get the unofficial stories of things that happened. For example, Buzz Aldrin, when he was stepping out on the moon's surface, the urine bag that was taped inside his boot broke. His first step on the moon broke the urine bag in his boot. So his adventures on the surface could have been like kind of one small squish for a man. He had a live open mic, so he of course didn't say anything wisely. But all sorts of, it's a human enterprise, and anytime you have a human enterprise, you're going to have things happen that you don't expect to happen. In front of us is something that we have expected to happen. We're looking at the moon continuing to chug into Earth's shadow. Now, this is a very interesting part of the moon right now. The eclipse this is a fascinating moment because the phase resembles that which you would see during a normal lunar phase, let's say 1 to 1.5, almost 2 days before first quarter moon every month. A fat crescent. This is a fat crescent shape, and it's one of the few parts of the eclipse that resemble a common moon. But it's very, very different what we're seeing. See, it's an illusion. Right now, that shadow that's covering the moon, that's right near the middle of the moon, is actually a flat shadow cast by Earth. We're just seeing the circumference of Earth. That's what it is. Whereas the actual phase, 2 days before first quarter, something else is happening. The sunlight is coming from the right, and that's the line separating day from night on the moon. So it's a line that goes around the moon from top to bottom and circles the moon because the moon is being lit up from the right. Tonight, the moon is being lit up from straight down. In other words, the moon is over our shoulder. The sun is over our shoulder, and the sunlight's coming straight down onto the moon. And so that line that we see in the middle of the moon is not at all the terminator separating day from night. That's the edge of Earth. Now, that's going to become more and more apparent in the next few minutes. We're going to see it go from a normal-looking crescent moon, that's what we see now, to an increasingly bizarre-looking non-normal crescent. We're going to see something that's very obviously strange and weird. I think the final 15 minutes before the totality begins, which it will at 22 minutes after the hour, I think those final 15 minutes, especially the final 10 minutes, that's coming up only in another 5 or 10 minutes from now, are the strangest parts of the entire eclipse. First, that's when we might first start seeing a little bit of redness to the moon, and secondly, it's going to resemble nothing that we normally see. So it's going to be really, really weird stuff coming up. After the break, I'm going to introduce our first guest of the night, and he's going to be with us for the entire next hour. And it's going to be a lot of fun, Duncan Kopp. And while we do that, we're still not going to leave our coverage. We're going to see this live lunar eclipse being brought to you by SLU, the space camera, and by Google. And we're also thanking Paramount for its support as well. This is very exciting as we see a celestial event involving 3 celestial bodies, Sun and Earth and Moon, happening right before our eyes. And if it's been interesting so far, It's going to get downright weird in the next 15 or 20 minutes. I promise you that. So we're going to go to a station ID break, and we're going to be back after just a few seconds. So stay with us for continuing coverage of the live lunar eclipse. I'm Bob Berman.
You're listening to SLU Space Camera's live total lunar eclipse, powered by WSRadio.com, the worldwide leader in Internet talk.
Hi, this is Bob Berman with SLU Space Camera and with Google, presenting you the live lunar eclipse seen from the Asian side of the world. We're watching the moon go more and more into Earth's shadow. And joining us for this next hour, I'm happy to introduce Dr. Duncan Kopp. And Duncan Kopp is who grew up in southwest England, got a master's degree, holds a master's degree in satellite remote sensing. That sounds cool, doesn't it? And a doctorate in astronomy, both from the University of London. He's done all sorts of very, very cool things. This is a very cool guy. And I looked at his picture, too. He even looks cool. He, I'm going to cover up some of the very, for other people this would be cool enough, but I'm going to even skip the lesser cool and go to what, to my mind, is the most cool, which is that a few years ago he conceived, developed, and produced the acclaimed feature documentary In the Shadow of the Moon, which was an intimate story of the Apollo astronauts, and this won all sorts of awards, including Best International Film at the 2007 Sundance Film Festival. It sold about 500,000 copies. I just got myself one in Blu-ray, and maybe you'd like to do it too. There's another thing he did that I like a lot too, and that's in 2007 to 8. He developed and produced and co-directed a thing called Moon Machines. It was a 6-part series for Discovery's Science Channel, which recounted the trials and tribulations of the engineers who built the machines that took the Apollo astronauts to the moon. And more recently, he's developed, directed, and produced The Planets, an HD Odyssey. Now, this is really interesting to me because the Holtz composition, Holtz, The Planets, we all know of it. To me, that was always like a dreary thing that was suited to narcoleptics. But he's made this instead into an exciting thing with the Planet Suite, which was commissioned and conducted by the Houston Symphony, and with that and with images around it, people have been wowed and knocked over backwards, and this has been an amazing thing that's produced more of an audience. It's the highest-grossing production in the 100-year history of that Houston Symphony. And there's a lot more. Maybe I'll talk about more of that later. But enough yakking as we're watching this lunar eclipse live. Let's welcome Duncan Kopp.
Hello, Bob.
Are you there, Duncan?
I'm here. Can you hear me?
Oh, absolutely.
Great. Well, I'm glad it's online because I'm sitting here at the Mayflower Studios here in the heart of Soho in London. And, of course, it's cloudy, so we can't see a thing. But thankfully, I've got my trusty laptop here, and I can see the feed, and I can see we're about halfway through the eclipse at the moment. So thank goodness for SLU.
Oh, yeah, it's great to have you, and I can tell the people who've been listening so far, Duncan's a great guy. He's a lot of fun. I wish we had callers on this show because this is a hoot that we're having. And Duncan, would you agree that we're just now entering kind of the weird part of the eclipse?
Yeah, I think so. I mean, I was listening to you earlier, and for those viewers around the world who can see it, if you stick your head out or have a look on SLU, it doesn't look that unusual. It looks like a sort of semi-crescent moon, or almost a half moon. But of course, all that's going to change, and the real fun stuff is going to kick off fairly soon when we finally get to totality, and the moon just goes this fantastic coppery color. And I remember seeing that as a kiddie, years ago for the first time. And quite honestly, it's a sense of you feel really little because you sort of remember that there are things out there, there are celestial events that don't happen all that often, but when they do happen, there's a certain grounding. There's a certain sort of sense of awe, I guess, really. And to think that the moon is going to be totally within the Earth's shadow and has that wonderful coppery colour. Of course, the real excitement is nobody really knows quite how coppery it's going to go. And as you were telling us earlier, Bob, that depends on just how much particulate matter there is in the atmosphere. And recently we've had a number of volcanoes kick off in Chile, for example. So who knows how much material is up there at the moment. But a sure indication is the colour that the moon's going to go. And of course, if you were standing on the surface of the moon and looking back at the Earth, you would see a pretty spectacular sight.
I wish we'd ever send astronauts during that time. You're so right. It would be when it's fully eclipsed, it would be the black nighttime hemisphere of moon surrounded by a ring of fire. All the world's sunrises and sunsets forming one beautiful ring. And that ring of red light is the only thing that's going to be illuminating the moon coming up just
fantastic.
Minutes from now.
I'd never thought of it like that, but of course that's exactly what it is. It's the sort of the whole of the world's sunset and sunrises, sort of all focusing through that tiny veneer, that really thin layer of our atmosphere, which we have, and of course the moon doesn't. I'm sure it's only a matter of time before there are people who are able to look back and experience that. In fact, the Apollo 12 astronauts on the way back from their mission in November 1969, after the first mission with Apollo 11 and Neil Armstrong, they were fortunate enough to fall into the Earth's shadow as they were coming back. And I remember seeing some spectacular footage that they took of the sun disappearing behind this planet, our planet, the Earth, and really eerie stuff, but wonderful nonetheless.
Yes, absolutely. Notice, too, this is, of course, not to you, Duncan, but who know this backwards and forwards, but to our viewers and listeners, how that shadow that we're seeing has not changed its shape since the very beginning of the eclipse, because we're seeing an arc, a section of Earth's shadow. Well, that's the same size and the same arc that it's always going to be. So from the beginning of the eclipse till now, that's invariant. What changes is that as it sweeps over various parts of the moon, it sometimes gives the illusion that we're seeing a day-night shadow on the moon, but now no longer could we pretend that, because even now the moon has become not a normal crescent phase that could ever be seen during an ordinary month. Even now the moon is, when do you see this in the sky? And for this remaining it's only about 14 minutes now before the total part of the eclipse begins. That what's left of the sunlit moon will take on a stranger and very unnatural appearance. This is my favorite part of the eclipse.
I think it's really cool, that shadow. If you think about it, that's probably one of the most important shadows ever, because as you were talking to us earlier, Bob, you were saying that it was really instrumental in understanding that we live on a globe and not on a flat planet that of course our predecessors once thought, and those who had the insight to observe these kind of events, it really was an eye-opener for them, and obviously a real cornerstone in the foundation of the fact, we're on a globe.
That's right. It's too bad that for thousands of years after that, after the ancient Greeks realized this, that most people still went on thinking we lived on a flat plane. In other words, it wasn't enough for them, the evidence right before their eyes. But yeah. I guess we shouldn't get you and me started on that kind of thing. Because you're doing a great job in bringing space to the public, even people who don't know any astronomy at all. And so you should get your own medal for doing that and opening everybody's eyes to that. I understand that you've also recently conceived and directed and produced something called Inside the Milky Way, a 2-hour documentary for National Geographic.
Yeah, that was a lot of fun. The premise of that film really was to take the viewer on this sort of journey across our galaxy. And you can think of our galaxy as a city, because it's not dissimilar in many ways. It's got downtown, which is the center of our galaxy where there's the hustle and bustle, and the density of stars down there is pretty high, and that's because astronomers are pretty sure that at the center of the galaxy is a pretty large black hole which has this huge gravitational attraction. So a lot of stars cluster down there. It's a vibrant place. It's a busy place. For life, perhaps it's a dangerous place. But then, you can always go out to the sort of leafy suburbs, out to the outer spiral arms where things quieten off a bit. And in fact, a lot of the stars that you find out there, they're a little bit middle-aged. They're not so adventurous. They just sit there and don't do much for sort of billions of years, really, on a cosmic scale. So the whole premise of that show was just to sort of take people around our Milky Way galaxy, a collection of about 100 billion stars, almost incomprehensible number that, but and show them these places where stars are born, places like the Orion Nebula, M42, places where stars die, like the Crab Nebula, which was a very spectacular sight, actually, that was observed by the Chinese astronomers. They actually saw this star blow up, and in fact, if you go and look where that star is now, you ain't going to see a star, but you're going to see a very, very rapidly expanding cloud of gas and dust, which was the remnants of that star. And we wanted to take people on this journey, and that really was the premise.
Good for you. And by the way, I hope people listening here do just that. I understand there's a special offer from SLU. I don't want to sound here like a salesperson, but you click on SLU here and become a member, and you can see the Crab Nebula that Duncan was talking about, and you can actually see the pulsar. Imagine a star that's smaller than Los Angeles. Can you imagine that? Can you imagine a star that spins 30 times a second? We can actually see that happening in all of it, the violence that kind of speed and activity, and some strange glow, synchrotron radiation. We're seeing colors that you can't see almost anywhere else in the universe that are caused by little subatomic particles, electrons being forced to change their direction because of the strong magnetic fields. You only see that in a few places in the universe, but you can actually see that for yourself at night. And if it's not on the schedule, you just press a button and make the telescope point there. You direct it yourself. It's SLOH. I love SLOH. SLOOH. I mean, they were responsible. The reason I'm talking it up is it's really thanks to SLOH and, of course, Google and Paramount as a sponsor for making this eclipse possible. And now that we've been speaking about the Milky Way and the eclipse, look at what's left, Duncan. Look at that little sliver. Now we can no longer pretend for 1 second that we're looking at a normal phase of the moon. This is obviously something. Imagine seeing that in the sky, just like a little piece like that, and if you didn't know that an eclipse was underway, what would you think? That's not a normal moon, is it?
No, it certainly looks very unnatural, and you can understand why people of old would look at something like that and think, hold on a moment, that's not supposed to happen. What exactly is happening? Even more so when you have a total solar eclipse, when of course the moon passes in between the sun and the earth, and they're, as you were saying, Bob, earlier in the show, a lot more spectacular. They're a lot shorter. But just imagine if you didn't have that prior knowledge and you suddenly see your sun. Just about every civilization depends on the sun, and it just goes, and you can't explain that. No wonder it would put the sort of a fear into you. Of course, today it's a spectacular event, and it allows us to see an area of the sun that you wouldn't normally see. This
spectacular.
You're
so right. So try, everybody. Try to get to a total eclipse. There'll be one next year on November 13th in Australia. I guess I should mention, because I'm not making any money from that a science tour company started something called Bob Berman Tours. I'm Bob Berman, so it sounds like I'm touting it for some kind of gain, but I'm not getting a penny from that. The idea is to get people to Australia or to under the Northern Lights easily, cheaply, without a hassle. And if you go on bobbermantours.com, that's going to tell you how to get to Australia just easily next year for the total solar eclipse. And if you don't use this, find your own way to go, because just as Duncan has just been speaking about total solar eclipses, which, if you think this is great, a total solar eclipse makes people weep, makes Animals go crazy. People weep.
It's the most bizarre experience. We had one that just clipped the United Kingdom in August 1999, and a group of us sort of decided to go and see this. And the weather wasn't fantastic, but we had a small break in the clouds. We were really fortunate, and we were on the island of Alderney, which is in the Channel Islands between the UK and France. And I tell you, it's just the most bizarre thing. You see this shadow creep up, and it came across the ocean. And Alderney's a tiny, tiny island, and it was absolutely inundated. There were.
Did you really get a clear breakthrough? I didn't know that anyone who saw it from England.
We had a very well. It was high cloud, so we were able to just about see what was going on. And when totality happened, you really are standing in the shadow of the moon, and there were just nobody bothered to turn their flashes off on their cameras. So it was just just a whole glittering island. It was incredible, and lots of weird things. We could hear Concorde because they were at that time Concorde was flying, and of course Concorde is was a pretty fast aircraft. Even when it wasn't going supersonic, it was subsonic. But you could hear it above because they were taking people on Concorde, flying along the path of totality. This is where the moon traces out the shadow on the surface of the Earth. So the people up there, I'm sure, were having champagne and having a much longer period of totality as Concorde races the shadow that's racing across the Earth's surface. But no, great time. We had a ball.
I'm glad you had a great time. Generally, and I'm going to tell this to the listeners and viewers here, when there's a total eclipse of the sun, the path is only about 150 miles wide, so you usually have a choice of places. Don't do what Duncan did. Don't go to Western Europe the next time there's an eclipse there. I was the eclipse astronomer on the Black Sea. That was better. That was clear. That was a sunny day. So to do that, I'm glad to hear. Duncan is just telling me of the very first reports I've had of anyone who saw anything from England or France, because I know it was overcast there. So good for you. I mean,
well,
hats off to you.
No, we were really, really lucky. I mean, it wasn't ideal, but it was enough to get a sense of what was going on, but fleeting. And as you say, the weather here in UK, it's pretty predictable, and that is rainy.
Might you go to Australia next year for that one?
Oh, I'd love to. Yeah, no, I'd love to if I got an opportunity to go out there.
Hey, join us on that thing, Bob Berman Tours. Just go on and do that.
Sounds fantastic.
And, maybe you can lecture with me on that. We'll talk about
possibly.
Hey, look at this eclipse. Meanwhile, notice the red is coming in.
Yeah, you can see it now, can't you? That's just starting to creep in there. Wow, look at that.
And so already we can tell you the world is not going to end. The Earth shadow really is coppery red, which is the normal color. We can already give you the news.
Isn't that spectacular? Look at that.
Yes. Aren't you glad, by the way, that this eclipse is not happening on December 21st, 2012? Imagine that, because that would be like one final sign of the end of the world, wouldn't it be? This to me is my favorite from here to when totality begins, which is just going to be a few short minutes from now. Is my favorite part, because you see the red, you still see a little tiny bit of the sunlit part of the moon on the right, and in a few more minutes when that gets smaller, I think it's going to look all the world like the planet Mars with its polar. There, even now. With the rest of it looking very Mars-colored.
Look at that.
And a polar cap on the right.
So Bob, what would the temperature be now? Because obviously it must be plummeting now that the surface there is in the shadow of the Earth. It must really drop very quickly there.
That's right. Now, as you know, the daytime temperature, especially near the center of the moon, on the middle of the solar day on the moon, is about in Fahrenheit. We're here in America. We're still Fahrenheit, and so it's about 240, 250 degrees. At night, easily enough, it falls to about that same temperature, but below zero. But will it drop that much in just a few hours without sunlight? No. So what we have to think of is, what would sand, essentially, silicon dioxide,
Uh-huh.
what would that do in the absence of sunlight over a period of only a couple of hours with no atmosphere? Of course, here on Earth we have an atmosphere that acts as a little bit of a blanket and stops it. On the other hand, the lack of an atmosphere makes the moon's surface a little bit like a thermos jug. In other words, the heat cannot dissipate to somewhere else. It doesn't have air to dissipate to. The vacuum acts like a protective way, so that the surface has a little more trouble dissipating its heat. So the bottom line is you're asking how much colder the surface will get, and I would guess that it's only during the eclipse, it's only going to drop maybe 20 or 30 degrees, but that's just a guess.
Okay.
What would you think?
So that's not as, I mean, when we were, you were mentioning moon machines there, and some of the engineers that I spoke with when we were researching and making that series, one of the biggest problems they had was this really big change in temperature, because, of course, if you're on the lunar surface, if you're in full sunlight, it's incredibly hot. But if you move into the shadow, you're dropping 200 degrees Fahrenheit or almost instantaneously. And in fact, what they had to do with the command module, that was the very top of the Saturn V rocket that basically blasted them into Earth orbit and then onward to the moon. They had to roll this spacecraft, and they called it the sort of barbecue maneuver, this rolling of the spacecraft, so that you would sort of equilibrate the temperature. So it was a bit like a chicken on a spit, and if you want that chicken to be evenly cooked, you got to roll it on top of the coals. And it was the same for the spacecraft. And I was told a lovely story once that I think it was Apollo 8, it would have been Apollo 8, which was the first time that the command module went to the moon, that astronauts went to the moon. They only orbited the moon, they didn't land, they just went to the moon. And they were all looking at their sensors, and all of a sudden somebody said, hold on a moment, this spacecraft's getting really cold. What on earth is going on? This was something they didn't know what was happening. And they thought, well, do we have a problem? Is there something wrong with this? And of course, what had happened is they'd gone into the shadow, and the shadow meant that the sun was no longer heating the spacecraft, and it started to drop in temperature. I thought that was a really lovely story.
Yes, and I'm glad the engineers thought of all those things ahead of time. You'd think that there'd be things that they overlooked.
With that particular event, I think it was something that got the hairs on the back of their necks sort of standing up a little bit, until they thought, no, hold on, we know what's happened here. They've finally gone into the shadow, which was very interesting.
Yes, and as we are now fully going into Earth shadow, as we're watching the moon, now distinctly red, but look at the left side of the moon. That looks quite dark. So in another hour from now, when we are more fully within the shadow, or let's say 45 minutes from now, I wonder how dark the moon is going to be then. And, talking about the Apollo astronauts, one of my favorite stories was, of course, Apollo 12, which was a very convivial crew. Apollo 11, when I interviewed Buzz Aldrin, of course, nobody gets to talk to Neil Armstrong, but one of the things that they admitted, and then Michael Collins said, is that although they were all very professional, they were all really great at what they did, they had a job to do, and they did it. It was cool. It was professional. But none of the others, this is afterward, this came out, none of them let the others in to his private thoughts, his feelings. They weren't friends. And even though Aldrin said that years later he had suggested an annual reunion, it never happened. And there was no close camaraderie. But on the Apollo 12, the people there, they were friends. The people who were doing that, Alan Bean and the others were all, they were friends before, they were friends afterward. So when they took off and their Saturn V rocket was struck by lightning, and the whole panel lit up with all these alarms and stuff like that, and they said, hey, we lost everything. Everything in the world's dropped out. And they had no idea what was going on. All the electrical dropped out, and they were They were on battery power. Nobody had ever seen anything like that. Everyone on the ground thought any moment there'd be the order to fire the escape tower rockets, and they'd pull the capsule away, and this mission was going to be scrapped. But because the problem seemed to be electrical, the flight director turned to his electrical expert, and this was that controller John Aaron, who later became the hero on Apollo 13, some months later. But he was looking himself at the screen, and he was just amazed. He remembered that he'd seen this pattern long ago during some kind of crazy simulation, and suddenly he remembered, and it came to him what should be done. And he told the others. He said to the flight director, "Tell the Capcom, the guy who talks to the astronauts," he said, "tell them to switch the FCE to auxiliary." And the director said, "What? What's that?" But he had the Capcom do it anyway. He said the exact directions. He had it relayed to them. And the astronauts, when they got that command on Apollo 12, with all the crazy alarms going off and all the electricity off, they said the same thing the director said. They said, "What? What's that? What's the FCE to auxiliary mean?" But Alan Bean, he knew what it was. He knew where it was. It was a never-used switch, a little tiny switch among one of the gazillion switches that were on a panel over his shoulder. So he flicked it, just as he was told, to auxiliary, and all the power and the gauges and the lights and the controls, all of them promptly came back, and the mission proceeded normally. And this one electrical guy in mission control, he's the guy who knew what to do in this insane lightning strike as the thing was going skyward. So, Duncan, when you're talking about, like, you never know, what kind of conditions are going to happen, and are they prepared for everything? It's so true. Yeah. And that's what makes the Apollo missions so exciting to you and me and anyone who's had anything to do with them. And that's why the people who think it never happened, that it was done on a Hollywood stage set, why that's so crazy.
Yeah, no, yeah, you're absolutely right. And I think it's the story you told there just beautifully illustrates teamwork. And that's what I came away with, and more so with Moon Machines, having sort of spoken to a lot of the engineers. It was a real camaraderie. Kennedy set the goal in the early 60s, and of course wasn't around to see it executed. And I think they all felt that after Kennedy's assassination that they just really wanted to carry on. But it was a sense of working together, teamwork, not giving up. They had umpteen problems. I mean, that's just a very trivial thing to say. Incredibly difficult thing to achieve. But by working together, they could make it happen. And everybody put 110% into that mission, as they do today in various areas of exploration. I think it's a trait of exploration. If you need it to, if it's going to succeed, it's got to be 110%. And I think that's borne out with all manner of areas of expedition. But picking up your point, we tentatively thought, well, do we ask the question, what do you think about the hoaxes, when we were making In the Shadow of the Moon? And we sort of thought, well, should we, shouldn't we? Well, yes, we should, because... Yeah,
you did, and at the end you had them all addressed.
Absolutely, because unfortunately it is something that the first thing people say to me when I was producing the film. A lot of people would say, yeah, of course, but it didn't happen, did it? So that's what they want to hear. So we asked everybody, and the retorts we had from the astronauts were hysterical.
They were good, and they were good retorts. They were good answers.
Of course they were.
One of them said, well, if we were going to fake it, why do it another 9 times after that?
Charlie Duke, who's just the nicest guy you would ever want to meet, and we've been to the moon 9 times. I mean, why would we fake it 9 times if we faked it?
Yeah, every time you fake it, you're going to risk being found out an extra time. Well, why keep doing it?
Absolutely. And Mike Collins, who was the command module pilot of Apollo 11, he's the chap that stayed in lunar orbit while Neil and Buzz went down and walked. And like he said, I don't know 2 Americans who have a fantastic secret without one of them blurting it out to the press. Can you imagine thousands of people able to keep this secret?
That's right.
I don't think so.
That's right. You know, when you talked about Kennedy's assassination, it brings up another aspect rarely discussed about the Apollo program, and that is that of all crazy twists of fate, the president at the time of the actual landings was Kennedy's nemesis, Nixon.
It was Nixon, yeah.
And here was poor Nixon with his used car salesman look and his, who had to watch as Kennedy, now even more elevated as a martyr, got all the praise for it. This was Kennedy's vision. This was Kennedy's Apollo mission, and there was Nixon who had to just stand sort of on the sideline. Of course, he didn't let that go too long. In the Apollo 11, as you know, he had the astronauts on the moon, Aldrin and Armstrong, stand sort of awkwardly at attention while he called them from I'm calling from the White House, as if the White House
I'm not sure that Buzz knew that was going to happen. Actually.
But these guys had to just stand there, sort of wasting their time while it was a long phone call that Nixon was. And I understand later when they landed and Nixon visited the men in quarantine on the ground, he made sure that one of his staff put the insignia of the White House just below the window where the astronauts couldn't even see it. And so that when the cameras were on Nixon, there was also the seal of the president on that window with the astronauts' faces. I mean, obviously Nixon was no fan of this thing, and it's no secret that and when he canceled the final three, he canceled, of course, Apollos 18, 19, and 20.
Yes.
Maybe that was one of the reasons. Of course, another reason could have been a very practical one, which was, why not quit when you're ahead? We already had the Apollo 13 near disaster. Why continue to send people to the moon? Each one was dangerous and risky, and sooner or later, if you kept doing that, some astronauts might not return. Why not just stop at Apollo 17 arbitrarily, and you'd finish up the Apollo program in glory rather than with maybe a tragedy, and so they canceled the final three.
Yes, but inherent, I think, if you talk to anybody who was involved in that phenomenal program, inherent in exploration is danger. It's not. They understand the risks. They know it better than anybody else, and I think people who sign up to that particular program know exactly what they're signing up for, and are willing to take those risks. And I think that's a mark of stoicism, really. They understand what they're letting themselves in for, but the drive is there, and exploration will always be risky.
Well said. I mean, should we not have come to America? Well, you didn't. And your ancestors, Duncan, you stayed back in England, but those of us here in North America, should we not have come here?
Well, how many people died coming to America? How many people died, going to Australia? It's not something that is necessarily. You can't get around that fact. I think you can do everything in your power to prevent it. But unfortunately, exploration is inherently risky.
That's right. In fact, some of the best things in life are risky. I don't know if you've ever had a motorcycle. I have for many years.
I was going to say, crossing the street outside, you want to try and cross central London. That's pretty risky.
Yes. I have a small plane, I love to fly, and some people say, well, aren't you afraid? But, those things that carry at least a little bit of risk are some of the best things in life, certainly. Yeah. Here we are, folks, with our SLU coverage. We have Dr. Duncan Kopp here as our guest tonight. We're very pleased and proud to have him. We want to thank Paramount and Google for their support. We want to especially thank Noel Gorlick at Google. He's the champion at Google in all of this. And, of course, the SLU space camera. And that's how you're seeing it. That's how you should be seeing it anyway on eclipse.slu.com. And we're just about, we're totally now within the Earth's shadow, and we can see it has this normal red color to it. All is well. It's not the end of the world. The Mayans were wrong. Wait a minute. They didn't say anything about this eclipse. Okay, so we can't blame the Mayans for this, but we're coming to the mid part of the eclipse at 22 minutes after the next hour, in other words, in 45 minutes, and that's really going to tell the tale as to whether there are any asymmetries in the Earth's shadow. Right now, it doesn't really look as if there are. We were thinking that maybe the volcanoes either in Iceland or in Chile could be causing more darkness around the limb of Earth. We mentioned earlier that if you were on the moon right now, you'd be seeing no sunlight because the sun would be behind the black cameo of an Earth. The Earth would be surrounded by a ring composed of all the Earth's sunrises and sunsets, whose bright red light is bent or fractured right onto the moon's surface. But that entire ring might have been broken. It might have been dark in some sections if volcanic ash had polluted the atmosphere, but so far it looks like it isn't. We're looking at a normal Earth. And by the way, we're also looking at the features on the moon, the mare, the beautiful solidified lava seas, and Duncan and I were just talking about the early Apollos, and there they are on the right side. You'll notice on about the 2 o'clock position on the moon, there's one isolated small round blotch. That's the Sea of Crises. Oddly enough, all the lunar seas that they used to think were seas are named either for weather phenomena or emotions. Strangely enough, they're all weather phenomena or emotions. So the one on the right is the Sea of Crises. There is an emotion for you. And to its left, there's a giant double blotch that kind of meet in the middle. It's almost like the number 8, and it's just to the left of that small Sea of Crises. The one on the top is the famous Mare Tranquillitatis, the Sea of Tranquility. Duncan knows all this. I'm just telling the listeners here. And the one below it is the Sea of Serenity. Serenity, tranquility, crisis, see, emotions. That's what we're looking at. And the Apollo, of course, the Apollo 11 was on that upper one, the Sea of Tranquility.
It's interesting you should say that, Bob, because the chap who wrote the music for our film In the Shadow of the Moon, Philip Shepard, I asked him, where did you get your sort of inspiration from? And obviously he draws on lots of different things, but one of the things he mentioned to me was, well, I looked at the names of the Mare, and I just thought they were really emotive and depicted human emotion, and I drew some inspiration from those names.
Left side of the moon is more is kind of a less well defined. There's more blotches there, and on the extreme left, the kind of the darkest part we're seeing is Oceanus. You'll see another one of the watery themes in Procellarum, if that's how it's pronounced. Never was sure about that one, and I don't know what that one means. I wonder if Duncan does. Or Procellarum. Oceanus Procellarum. That's the dark blotch on the extreme left. I mean, we know what tranquility and serenity and crises, what all of those are. In fact, the blotch on the lower right is Mare Nectaris, the Sea of Nectars. That's kind of pretty, but Procellarum, what's that? I mean, were you forced to take Latin in school, Duncan?
No, unfortunately not, and it's a shame really, because funnily enough, for a lot of the things that I've studied when I was at university, of course, the nomenclature comes from Greek and Latin, and it was interesting because my father he had to do it. This was, way back when. And so I would say a name to him, a geological name, for example, like pyroclastic, which is basically something that's thrown out of a volcano. It's called a pyroclastic. Well, pyro means fire, and clastic means broken fire. And he could deduce that, you see. And I thought that was really smart. So it's definitely something that I think would have helped me. But you pick it up as you go along, I guess. Oh, well, you pick up some of it.
That's right. We were not like those of us in the physical sciences. We were not like the medical people who were forced into more Latin than we were.
Yeah.
It's a shame. I watched Jeopardy, and most of the Shakespearean plays, I tell myself, I should know this better. This is terrible. I'm a writer, so. In any case, this is our coverage of the live lunar eclipse. This is SLU, the space camera. And, wow, this has been an amazing event so far. We have Dr. Duncan Kopp from London. I'm Bob Berman here in upstate New York, in the mountains of upstate New York, near Woodstock, which is no longer a hippie capital, by the way, just in case you wonder. Summer home, more like a summer home capital in the mountains. And it's good to be here. We've talked about Duncan before and some of the amazing things he's done. And more recently, a thing called The Planets, a high-definition odyssey on the planets, which I've not seen, but I really look forward to seeing, and a bunch of other things, too. It's just fantastic having him. For my part, Bob Berman, I'm just, well, I shouldn't be too modest, that sounds falsely modest. I'm the astronomy editor of the Old Farmer's Almanac. That's the original Farmer's Almanac, the one with all the yellow on the cover. And an editor of Astronomy Magazine. Great to be here tonight and be part of this SLU and Google process by which we have people situated in various parts of the world, and they're standing there now. I want to thank Matt and Paul, who are out there in the freezing cold night. Well, maybe it's not so freezing in Dubai or Cyprus at this time of year. Maybe I'm giving them more credit than I should. This is not a January eclipse, but still, they're out there looking at this gorgeous eclipse. We're approaching, not yet at the mid part of the eclipse, and we can see that the moon has turned a normal color. It could be black, could have disappeared, could be beige. There have been eclipses that barely turned any color at all. So there's all sorts of gradations of possibilities, but instead we're looking at a normal-looking eclipse. Duncan, what would you like to talk about regarding the moon?
Oh, well, where to start, really? I mean, the great thing about the moon, well, I always think the great thing about the moon is it's always there. You know, it's always like, it's almost comforting to sort of watch its phases and see it wax and wane. And I've always been intrigued by that. It's a great measure of time. It's some sort of degree of stability, I think. And I think you were mentioning earlier about previous civilizations, and you can understand how they became comforted and in fact based their, well, I mean, a lot of their lives around the moon. And it always amazes me at just how skilled a lot of previous societies were in being able to predict lunar eclipses and predict the phase of the moon and use it as a calendar and use it to indicate various aspects of their lives. And in fact, it's permeated through the sort of fabric of society today. There are so many terms and parts of our lives that still revolve around this lunar phase. But I guess for me, I really got to know the moon when we were working within the shadow of the moon, and we got to meet those people who I always sort of think it's one of the most elite clubs in the world, if not the most elite club, which is the surviving astronauts who walked on its surface.
That's
and,
right. Nine are surviving,
that's right? Yeah, exactly.
I mean, they're getting on there now. They're in their 80s,
well, they are,
aren't they?
They are in their 80s. Now, I would have met them when they were a little bit younger, sort of late 70s, but still incredibly sharp, very lucid, wonderful stories to tell.
And interesting, too, as you brought out, how the moon has changed each of them, how being on the moon has in very different ways.
Yes, that was really interesting, because I think, thinking about it, and each one, they're a very eclectic group of people, obviously a very, very intelligent bunch of people, and they have a commonality with regards to their training, but each one of them, from my experience of the ones that I met and had the opportunity to talk to, are very individual. And Alan, you mentioned Alan Bean, who flew on Apollo 12, is an artist and a painter. Charlie has a deep faith, and
that's Charlie Duke, right?
That's Charlie Duke, who flew on Apollo 16. But what I thought was interesting is it seems to me that once you've gone to the moon and you've returned, how do you top that? And it seems to me that traits that they had, I don't want to speak for them, but traits that they had before they went to the moon, i.e. an interest in faith or art or whatever it may be, was magnified by the experience. So coming back, they decided, perhaps they wanted to spend more time and pursue the things that they'd always been interested in. But a very interesting bunch of people with, if you think about it, a really amazing experience. It's a bit shameful, but I always used to look at their feet, and I used to think, those feet have, they've left footprints on the surface of the moon that are going to be there for millions of years, because there's very little erosion on the moon. There's no wind, there's no water. So any footprint that you leave on the lunar surface in that very fine powdery soil that you were talking about earlier, Bob, it's going to be there for such a long period of time. And if we ever go back to the moon, and I'm sure we will, it's just a matter of time, those places will probably become sites of scientific interest and maybe even museums. But those footprints will always be there. And it was interesting to meet the people who, the very, very top of the pyramid, those were the people who actually got to lay those footprints. And as you mentioned earlier, sort of 400,000 people who worked very, very hard for a long period of time to make it happen.
And although you didn't mention it in the movie, in that very fine movie of yours, I understand that the astronaut who left a photograph of his kids, of his family on the surface, the others regretted not doing that too.
Yeah, that was Charlie Duke. In fact, I think we have the picture in the film, but I can't quite remember now because I've seen that picture so many times. But a lovely gesture. I know he took in his flight plan. There were notes from his kids as he was traveling out to the moon, and Charlie always says this lovely piece at the beginning of the film, which was his father was born shortly before the Wright brothers, and he could hardly believe that Charlie was going to go to the moon. But his son Tom, who was 5, didn't think it was any big deal. And I think that's a wonderful shines a very bright light on how quickly technology propulses us forward, pushes us forward, propels us forward.
Quite so. I wonder how that photograph is going to endure. We're going to have our next guest, by the way, in another 40 or 45 minutes from now is going to be Dr. Lucy Green, also a Brit and also an astronomer, professional astronomer. Her field is the sun, and she's going to talk about how the sun's intense bombardment with its electromagnetic radiation and its particles have changed the surface of the moon that we're looking at. So I would think, Duncan, that it's going to pretty much mess up those photographs before too terribly long. But
I don't think that photograph lasted very long at all. In fact, I think it was a matter of minutes before it had curled because of the surface temperature there. So I think I'm right in Charlie telling us that it was there for just a fleeting moment.
But it is interesting, going back to what you were talking about, how different the different astronauts were. Buzz Aldrin made no secret of the fact that he could not live up to the fame and had problems with alcohol. He checked himself into a mental hospital. He had a lot of problems after his time on the moon. Neil Armstrong simply became a recluse. Others turned to religion. Edgar Mitchell became arguably the wackiest of them all and got into psychic phenomena.
Well, I think this is the point I'm trying to make. I think to us it may look a bit weird and wacky, but I don't think actually it was. I think all of them had these interests before they went to the moon, but the experience I think magnified their interests. And I think sometimes they get a bit of a raw deal from my perspective, because obviously, going to the moon is going to change your life, but it was an area that perhaps they didn't have any training in. They trained just about for every other eventuality, but to train for that kind of fame was perhaps something that was overlooked and would naturally be something that's quite difficult to come to terms with, because they haven't changed, but the way we perceive them changed, and changed radically, and changed overnight. And so from their perspective, nothing's different. But for us, these men have gone to the moon. I mean,
well, except some of them were different. Remember how was it Edgar Mitchell who said he had this kind of epiphany?
Yeah.
That's right. That's how he put it in your film. That he saw a oneness in everything, and that himself and Earth and everything was one. He said it was an ecstatic experience. But again, he is the one who embarrassed NASA a little bit with those ESP cards on the moon. Remember?
Well, I think he always had an interest in that particular area, and I think naturally it was something where better to try and explore his particular interest. And that's the other thing. You're only ever going to go to the moon once. It's at least walk on it. There are a couple of astronauts who were fortunate actually to go to the moon twice. So you've got to be yourself in some respects. You're human, and you take your human traits along with you. I don't think there's any dispute about that. And I just think sometimes we make slightly too much of these things. I mean, they had an amazing experience, and I think for a lot of us, if we had exactly the same experience, we would probably see ourselves and see the way that we perceived in a very different way. And perhaps that was hard to come to terms with.
Yes, I think so. I think you're quite right. I think Buzz Aldrin may have had the hardest time.
I think so. I mean, it's a bit like, if you win, I don't know, Pop Idol, X Factor or something, suddenly you're propelled from being totally unknown into millions, hundreds of. I mean, at the time, the Apollo 11 landing, the television coverage had the highest viewing figures ever. So all of a sudden, you become instantly a household name. And again, I don't think that really entered into the day-to-day training when they were trying to grapple with the complexities of flying the lunar module. That was their job. That's what they had to do. But of course, it was inevitable that something as successful as landing on the moon and returning back safely to Earth is going to propel you, and it's going to change your life. The irony is, it only lasted a couple of days, and it was 40 years ago, but it remains with them throughout the rest of their lives, really. Something they have to live up to, as Buzz said in the film. Interesting.
Yes. I was a little surprised. I mentioned this when you and I spoke the other day, that I was surprised during the just 1 hour conversation. I know you spoke to the astronauts a lot longer than that, but the 1 hour I had with Buzz Aldrin is that he was still steaming mad over the selection process. He almost didn't get to the moon, even though he was so well qualified, and he blamed it on being Air Force. That he was one of the few eggheads. He was one of the few with a PhD, and he was distrusted. He said all the others were Navy. He said to me, "Just count them, count the astronauts, where they were from, where the others were from. It was all Navy. I was the only Air Force, and they left me out. They left me out on everything. And he only flew on the final Gemini flight, the one in which he earned his moniker of Dr. Rendezvous.
Yeah.
He only flew on that because of the death of the astronaut that was supposed to have been there. He was a replacement. And
sadly, that's right.
And he got slipped in the last moment, and when he performed so well, that's the only thing that even got him into that flight in Apollo. So, but you'd think after being on that first landing on the moon and all that success, 40 years later, he would have let that go. But he's still steaming mad.
Well, I think you have to look at it this way. It took two people to get down there. It took two people to get off again. It's as simple as that. And I think you can't really underestimate the intellect that Buzz brought to that program, because he was instrument in figuring out how to achieve rendezvous in space, which was
he did it manually in the final Gemini 10. The computer went out and he manually was able to fly the Gemini to its rendezvous with the Agena target spacecraft. He did that on his own, just from his own knowledge in his head.
Absolutely, and he was smart. I mean, I don't think any other astronaut would argue that point. And he was also the spacewalks that he conducted on that last Gemini mission were critical, absolutely critical.
And he nailed it. He absolutely nailed it.
Exactly. And you're always going. It is unfortunate because, of course, unfortunately, I guess that's what people always say. You were the second, but only by a couple of minutes. And quite honestly, again, it's what we were talking about earlier. It's a team effort.
It's a team effort, but he still
relied on each other.
I know, but he's still bothered by that. He's still bothered being second because he complained.
I think what bothers him is maybe more. What bothers him is not having perhaps the recognition that he deserves, and also, of course, it's one of those things. I mean, I can't speak for him, obviously, but I know that if I were in that position, it would be a bit grating if all you ever hear is, so, you were the second, rather than, hey, look, amazing the work you did on orbital mechanics and rendezvous.
That's
Thank
right.
goodness you did that. Otherwise, actually...
But he has to hear. I just heard it this morning on the radio where somebody mentioned the first landing on the moon. This was the... and we're celebrating when Neil Armstrong took his first steps on the moon. No mention of Buzz Aldrin.
No.
And also the protocol, his commander status although he was second in command, the normal status was that he would exit first. He was certainly closer to the door. The normal protocol is he should have left first. Yes. And it was Neil Armstrong who told him not that long before the actual Apollo 11 flew that Armstrong was exercising his prerogative of the highest ranking person on that mission, and that he was going to leave first. He was going to squeeze around Buzz Aldrin and exit first, and
the rest is history.
And the rest is history. And who could blame him? I mean, Neil Armstrong. You and I may have done the same thing. Even though Armstrong has proven over time to be a quiet, almost shy, reclusive, introverted person, he didn't act that way then, and who can blame him? You get one shot at being the first person to land, to step on the moon. No other person will ever be able to say that, and who among us would not take that opportunity? And meantime, we're talking about the first people on the moon, and we happen to be looking almost right at it. Even though the moon is fully in eclipse, we can still see those solidified lava blotches very easily, and there is the landing site of Apollo 11. Go up from the center of the moon, go up in approximately a 1 o'clock direction, go about halfway from the center of the moon to the edge, and you will be at the Sea of Tranquility site where the first astronauts landed. Interestingly enough, the place where the final astronauts landed, Apollo 17, is right near there too. It's right near the spot where those two large blotches on the upper right of center, where they come together, is just about the spot where Apollo 17 landed on the moon. So we get a 2-for-1. Actually, we get an all of them for one, because all the astronauts landed on this part of the moon that faces us, the near side of the moon, and they all landed in a place between the center and about halfway to the edge. None of them landed along the limb or along the edge of the moon. So we were actually all at once taking in the entire field of all the landings on all 6 places where the Apollos landed on the moon. It should be mentioned that a lot of people think that there's a dark side to the moon, and a permanent dark side, but of course there is not. There is a near side. One side always faces Earth, and there's a permanent far side, but all parts of the moon get night and day in about 2-week increments. Now, Duncan, even though we had scheduled you for an hour, I wonder if you'd be kind enough to stay with us after the break, maybe stay for another 15 minutes. Could you do that?
Yeah, no, I can stay as long as you want. I'm enjoying it very much. Thank you.
Okay, well then, very good. We're going to do that soon. We are approaching the midpoint of the eclipse here. We, of course, want to thank Google and SLU for making this possible. And the coverage of the moon with our guest, Duncan Kopp. We're going to have another guest soon as well. I'm Bob Berman, and it's thanks to Paramount and Google and SLOOH, S-L-O-O-H, for making this live coverage of the lunar eclipse possible. So we will be taking a station ID break, very brief one, and then we'll be back after just a few seconds. So stay with us for continuing coverage of the live lunar eclipse.
You're listening to SLU Space Camera's live total lunar eclipse, powered by WSRadio.com, the worldwide leader in Internet talk.
Okay, we're back covering the live lunar eclipse. We have tech people around the world, South Africa, Dubai, Cyprus, monitoring the eclipse. We're going to reach the midpoint of the eclipse, which is a special moment. Actually, in solar eclipses, it's a very special moment, but in a lunar eclipse, which unfolds kind of in slow motion, it's special because we're going to be able to inspect the moon for any asymmetries which reveal odd things happening on Earth. This is the only occasion when we can look at a celestial object in space and get a report card about our own conditions here on Earth, our environmental atmospheric conditions, and we'll be able to really assess that coming up at mid-eclipse, which is only another 10 or 11 minutes from now. We have Duncan Kopp as our guest. A little bit later on, we're going to have Lucy Green. These are astronomers from England. I'm Bob Berman of Astronomy Magazine and the Old Farmer's Almanac. And since I have no shame, I will plug my new upcoming book called The Sun's Heartbeat. Will be published next month by Little Brown. And that's it. Hi, Duncan. We're back.
Hello there.
So a nice eclipse, isn't it?
Yeah, it's beautiful. I'm just looking at it with the SLU camera here online. It looks fantastic. Where's that feed coming from?
Well, we have Dubai. I think the current feed that we're looking at is Dubai. We have Matt and Paul and the SLU techies. Normally SLU, we have a giant half-meter telescope set up on the Canary Islands, and anyone who signs up to become a member controls it from their own computer. You press a button and boom, the computer moves, and every 5 minutes there's a different object in full color live happening. For example, there's a supernova going off in the Whirlpool Galaxy. We're going to be looking at that tonight at SLU. Just amazing celestial objects. What kind of a world is this where from your own chair, sitting in front of your computer, in your underwear, you can make a telescope on the other side of the world, change your direction, and point to any celestial object you like. For example, last year we were really mesmerized by Jupiter. Jupiter's going to be out again very soon. It's been behind the sun the last few months, but Jupiter lost one of its two main belts. Anybody with even almost a toy telescope knows that the most prominent features on Jupiter are the northern and southern equatorial belts. Well, the southern one just went boom and vanished, and it was gone all last year. We watched the red spot swirling around its moons going around it and cast its shadow, and all of it changing before our eyes and being live. So it's very exciting. I have to tell you, I don't get paid any extra for raving about SLU, but it's hard not to, because
it's great. I mean, I'm totally new to SLU, but it sounds like a fantastic idea. And I guess the real advantage is if you live in a city and you've got all that urban light pollution, and you want to try and capture something, you want to go and see something that you know that's happening. I assume then SLU is the place to go.
Yes, or if you want to just supplement your astronomy hobby, even if you live in dark locations, it's no secret that even the largest backyard telescope only shows galaxies and nebulae in black and white. And that's because at low light levels, our eyes switch to their so-called scotopic vision, and which is always black and white. Here's something a lot of people don't know, that in faint light, our best vision is 2200. In other words, we're legally blind. You can prove that for yourself tonight. Just turn the lights off in your bedroom, and if all you have is a little night light or maybe a little light coming up through the window under a curtain, look around, and all the detail you might have seen on the floor, whether you have a carpet and could have seen every little thread in the carpet, or a wood floor, you see the grains in the wood when the lights are bright. Now in dim light, once your eyes get used to the dim light, which takes a few minutes, but once they do, suddenly everything is very blurry because your vision is 2200 in faint light. So using a backyard telescope, even the most expensive backyard telescope, galaxies are still very faint. Their surface brightness is still so low that we're using our rod-shaped cells in our eyes. We're using scotopic vision, and as a consequence, we are seeing the Whirlpool galaxy and every other galaxy in 2200 blurry, and in colorblind, because faint vision is always colorblind. So it doesn't resemble those beautiful images with astonishing detail and gorgeous color, with those cobalt-colored spiral arms and the campfire-colored cores of galaxies that we see in, let's say, magazine photographs. But with SLU, you see it, because all of it, even though it's live astronomy, you see the true detail and the true color. So even if you have a backyard telescope, this is I think, an important supplement for exploring the universe. And I don't want to get too obnoxious and keep raving about SLU. So let's turn back to this live lunar eclipse we're looking at. And I think maybe Duncan and I will talk a little bit about the moon that we're looking at. I mean, obviously we're watching a round body, but let me tell you how round it is. The moon, when you look up in the night sky when it's perfectly full, you are looking at perfect roundness, because the moon is only one part in 500 out of round. It's 2,160 miles across, and it's only 4 miles from that, deviating from a perfect circle, and no eye can discern that. So just as the sun is perfectly round, the moon is also one of the few perfectly round things that the eye can ever see. Kind of cool.
It's beautiful. Hey, Bob, I want to ask a question. Can I see some stars here? Do you see... are we picking out some stars? There seems to be one very close to the limb at about sort of 4 o'clock-ish.
That's right. I see some, and I believe that we are seeing stars there, yes, because we've now changed the exposure to capture this dimmer moon, and we're seeing background stars. And those who are in position to see the moon right now, that is, if you're in the Middle East or Asia, and it may even be happening for you around now. Isn't it around twilight or sunset for you, Duncan, in London?
Yeah, it is. It's just after 9 o'clock here, so we're almost at the longest day, so it's still quite light outside.
Okay. Well, the moon is, it's always fascinating that the full moon is opposite the sun in the sky. A lot of people don't realize that, so that as the sun is setting, that's just when the full moon rises, when the sun is at its lowest, at around midnight, or 1 o'clock during daylight time, or summertime as they call it in England. That's when the moon is at its highest, just when the sun is lowest, at around midnight. So everything is opposite the sun. And so in London there, where the sun is close to setting, that's when this moon will rise. It's very easy to predict. Another thing about the full moon is that it's even opposite in every possible way. This time of year, as Duncan just pointed out, is when the sun is highest in the sky. We're only, a week or so from the summer solstice when the sun is highest. Well, that means any full moon at this time of year will be the lowest full moon of the year. It'll have the lowest path through the sky. We'll see it through the thickest air near the horizon, and maybe that's the origin to that term honeymoon, because weddings were for a long time traditional in June. I understand that these days September is the most common month for weddings, but it was June for a lot of months, and maybe that's where the term honeymoon comes from. Fascinating. Oh, let's throw other moon facts at us. We already said just over 2,000 miles from side to side. So if you place the moon, let's say, over the United States, with the right side over, let's say, Boston or New York, the left side of the moon would just about be over Denver, Colorado, that area, just so you get a sense of what kind of size that we're talking about. And with its density, which is not, it's not as crammed full of stuff as Earth is. Its density is about 3.3 grams per cubic centimeter. You take a little sugar cube worth of substance of the moon, and it's going to weigh about 3 1/3 grams. Earth, on average, weighs 5.5 grams, so we're the denser body. And so if you add that together, it means that the moon weighs 81 times less than Earth. You'd need 81 moons to equal the sheer weight of the Earth. So always interesting to get a sense of what we're looking at with the moon. We're also looking at one of the darkest objects in the known universe. Now, maybe it's odd to talk about that now because it's an eclipse, of course, that we're seeing. In fact, the very middle of the eclipse is only about a minute and a half or 2 minutes from now, the central part of the eclipse. But we're looking at an object that is as dark as black paint, or close to it. Hard to believe that if you took the moon and wanted to compare it to an object on Earth, the nearest thing you could find would be asphalt, a parking lot. So if some insane developer went to the moon and paved it, turned it into an entire parking lot, paved it with asphalt, the truth is it would be no darker than it already looks in the night sky. It's got a reflectivity of only 12%. It bounces only 12% of the sunlight that hits it. Black paint is about 10%, so it's pretty darn dark. And speaking of that, all of this has taken us to right now, the midpoint of this lunar eclipse. We're right in the middle of it now, and so, Duncan, we can look at it and decide whether there is any asymmetry or irregularity. What do you think? What are we looking at?
Well, first of all, I think it's absolutely beautiful, and the image we're getting back here now is stunning. And as I say, I'm deep in the bowels of the Mayflower Studios here in Soho, and I can't see outside, but what I can see on my little laptop here is this wonderful image. It looks to be pretty even to me, Bob.
It does to me, too. A little bit of a surprise that we're getting such a normal eclipse since we've had such, a spate of volcanoes erupting, and normally that'll make it for a blacker eclipse than usual, since the light that's hitting the moon, we said this earlier, but it bears repeating, is the light from the edge of Earth, so that if you were on the moon now looking back, you'd be seeing no sunlight, because the sun is behind the Earth in the sky. The Earth is just inky black, but it's surrounded by a red ring of all the world's sunrises and sunsets, and that ring of fire is what's illuminating the moon at the moment. But that ring doesn't have to be symmetrical. Very often, if part of Earth is more polluted, cloudier, have volcanic eruptions, you'll get one section of that ring that'll be darker than the rest, and therefore the light that's bent or refracted onto the moon's surface will make for one part of the moon to be darker than the rest. Instead, we're seeing a pretty darn even redness on the moon, and that means that despite these volcanoes and despite all the bad news in the newspapers, Earth is normal.
Pretty amazing shot, isn't it? Look at that.
It's gorgeous. We're now at mid-eclipse, just absolutely stunning. The moon is going to shift its position. You know, Duncan, you were talking about the background stars. We see one just to the right of the moon. Yeah, there's another star above it. Maybe we should point out that the moon moves through space one diameter per hour. The moon is a half degree in size. And that surprises a lot of people because most people remember the moon as being larger than it really is. I've found that if you ask friends, and just ask people who are not astronomers, to rate the size of the moon. And, of course, since people don't know how to use degrees in their mind, you could put the question this way. If you were to stack full moons, one atop the other, how many moons do you think it would take to stretch from the horizon, the skyline, to straight overhead, the zenith? How many moons would it take? And that's a way for people to assess their recollections of the size of the moon. And most people, I found, will say something like 40 or 50 or 60 moons. The real answer is 180 moons are required to stretch from the horizon to the zenith. Since there are 90 degrees in that span, it means the moon must be half a degree. Same size as the sun, and it's another astonishing coincidence, if you believe in coincidences, that we only have two disks in our skies. We were just talking about how both the sun and the moon appear perfectly round. Those are two of the only round shapes we ever commonly see. And these two disks are both the exact same apparent size. That's why the moon so perfectly fits over the sun for those spectacular solar eclipses. It's not larger, substantially larger. It's not smaller, and if it is, sometimes during the far part of its orbit, it's just barely smaller. They're really the same size disks, and if either the sun or the moon were nearer or farther or larger or smaller, you wouldn't have that. And we didn't used to have that because the moon used to be closer to us, and since it's spiraling away from us at the rate of 1.5 inches a year, we're not going to have it in the distant future. So it's only really for now, when humans are on Earth, that we have the moon and the sun being the same size in our sky. Another thing that people used to think was almost a sign, a divine sign, and a lot of people turn to astronomers for their religious beliefs. For some reason, Duncan, I know you've had this as well. People think astronomers have some sort of extra handle on the nature of the universe. And
I wish I did.
People always are trying to figure out whether the universe has some divine plan or whether it's random, and people often look to astronomy for that. And they used to think that one sign of a strange divine plan rather than a coincidence is the fact that the moon spins in the same period in which it goes around us. Its orbital period is 27.32166 days. I have to remember these things exactly. And its period of rotation is the same thing, 27.32166 days. And people would say, well, what are the chances of that happening? But now we know that even though the sun-moon same-size business is really either an amazing coincidence, there's no reason for it, but this other business isn't, because we've found only in the last few decades that every moon of every planet has the same spin rate as its orbital period around its parent planet. Or put another way, every single moon has one side that faces its parent planet. So our moon is not the oddball. It's not an oddity. Tidal forces have done this to absolutely every moon in the solar system. So there it is. There's the same features that we always see, because that's the side that always faces us.
I think that's a really interesting point you raised there, Bob, because it's one of those points that as we learn more and more, as we learn more about the universe around us, what once appeared to be unique and special actually perhaps isn't as unique or special as we thought it was or wanted it to be. And the same goes with things such as planets, exoplanets around other stars. It's incredible to me to think that 15, 20 years ago, we only knew of 9 planets around our sun. Now there's a plethora of them out there. I think, getting on to close to 1,000.
That's right. Even though we lost Pluto, the others have more than made up for it.
Yeah, exactly. But we're getting this. I'm just seeing the feed now from Dubai, the live feed from Dubai here, and it's absolutely stunning. It looks like we're right in the darkest part of this of the Earth's shadow there. It's beautiful.
We're right at mid-eclipse. Now we're going to have our next guest on, and I hope you'll stay with us, Duncan, because you will understand her since you're both from the same part of the world, we won't need subtitles. We've been running subtitles so far over the images for your British accent, but you two will not need it. We're going to have Lucy Green, who is a noted astronomer, expert on solar astronomy. We're going to have her on in 10 minutes from now, and we're looking forward to that as well, as we have just now passed the midpoint of this live lunar eclipse. Fantastic. Duncan and I, this is Duncan Kopp, a astronomer in Britain. I'm Bob Berman here in upstate New York. Lucy is also, who's going to join us, is also in Britain. We'll have her on in about 10 minutes. And we want to thank the people who made this possible. You know, a lot of people had roles in this. First and foremost, there is SLU. I hope you're watching this on eclipse.slu.com. And it's SLU whose technical work is making this live eclipse possible. And we also want to thank Paramount for sponsoring it, and Google for presenting it as well. And again, if you want to see more celestial things, live astronomy, definitely click on the Google site, or go to slu.com, and there you'll find a way to become a member and see live astronomy all the time instead of just during the eclipse. So, what are your thoughts? What is this making you feel, Duncan, seeing this?
Oh, I think it's beautiful. I mean, it's just stunning. I mean, again, as I say, it's one of those events that makes you appreciate that we do live on a rock and day-to-day life occurs, but once in a while you look to the heavens and something happens that makes you. But it puts things in perspective for me. And as I say, the feed here from Dubai, the telescope in Dubai, is just wonderful. It's interesting you were talking about eclipses. When I was working with the Houston Symphony for the project I did with them, it's called The Planets, an HD Odyssey, and you were talking a little bit about that earlier. One thing that we did is we went back and looked at a lot of data from some of the spacecraft that went to other planets, and one of them, Cassini, that has had the most successful mission. It's breathtaking, the images, is in orbit around Saturn, the ringed planet, which is beautiful. But Saturn has this entourage of moons, and Cassini, the spacecraft, has been able to capture these movies as these moons dart in and out of Saturn's shadow. So these moons that orbit Saturn are constantly going through this eclipse cycle. Of course, we only have one moon, but the outer planets, the gaseous giants, Jupiter, Saturn, Uranus, and Neptune, they have a whole suite of moons. And it's wonderful to watch this sort of celestial dance as these moons dip in and out of the shadow of their planets that they orbit. And pulling some of those images together and setting them to music, and it's almost the harmony of the spheres. And the Houston Symphony obviously perform Holst's The Planets, and Holst had no idea that these worlds existed when he wrote his music, and so it was a joy to be able to have that opportunity to put these images to the music.
Well, how would one obtain that? Is it available?
Oh, yeah, it is. It is. I mean, there are a number of places in the U.S. where various orchestras are going to play the Planet Suite to the visual presentation that I made for them. But if you wanted to get hold, we made a DVD actually. We made a DVD and a Blu-ray of the live performance. So you see all the pictures that I use, and you see and you hear the music as well.
So what is it called again? How would one find it?
It's called The Planets, an HD Odyssey. And I guess the best way is to go to the Houston Symphony, their webpage, and it's www.houstonsymphony, which is all one word, .org, O-R-G, and there's a little icon there of Saturn, and if you click on that, and if you wanted to get hold of the Blu-ray or the DVD, you'd be able to. But we were able to plunder all these beautiful satellite images, and you realize that what's happening now live in front of us is not unique to the Earth at all. In fact, all the time throughout just our solar system, there are constant eclipses as moons and asteroids and ring particles move in and out of the shadow of the various planets that they orbit. So it was a wonderful. It was just very evocative, I think, to put those images to music, and to think that Holst really, at the turn of the last century, had no idea that these bodies existed. And we actually, that there's a sort of a bonus DVD that you get if you buy the if you buy the production. And I went back to the Jet Propulsion Laboratory there in California and interviewed a lot of the scientists and the engineers who built these spacecraft, and they tell the most wonderful tales of what it took to construct the spacecraft, send the spacecraft out, and watch the images come back. And I think even they have seen various images. Of course, they get to see all the images that really are quite spectacular. And
what a time to be alive, isn't it? What a time.
Oh, absolutely. It really is a golden age of astronomy and space exploration. And I think a lot of, in the future, a lot of people will look back and think of Hubble and think of Cassini and think of Voyager and the lunar landings as a real golden period of exploration. Long may it last.
This is Bob Berman, and we are looking at the live lunar eclipse presented by SLOO and Google. SLOO is SLOOH. You're probably watching this on eclipse.sloo.com, but certainly sloo.com will take you to other wonders of the world if you wish. And I'd like to introduce our next guest. She's a solar expert, and since we're in a plugging mood right now, I'm going to unashamedly say that my book, The Sun's Heartbeat, published by Little Brown, will be out in a month. And it's only because of writing this book that I can probably not come across as a complete idiot while I interview our next guest, Lucy Green. Now, the sun is, of course, the nearest star, and it is sunlight that we're still seeing on the moon, even though the moon is fully eclipsed. So let me welcome Lucy Green from England. Are you there?
I am here. Hi.
Hi.
Hello, Lucy.
Hi.
So what do you think so far? What do you think of this eclipse?
Oh, it's been fabulous so far. And actually, I'm looking out of the window in the UK, and it's kind of clearing up. So I'm hoping to catch the tail end or be able to see it out of my window later on.
Hooray!
It's been fabulous to see it through SLOO.
And could you tell us something about, you told me on the phone the other day about how, I was wondering how we were going to tie your sun expertise in with a lunar eclipse, and you pointed out that the moon's surface is changing because of being hit by sunlight. That's true, isn't it? Yeah,
that's right. So the moon is being bombarded by sunlight, but also by particles coming from the sun. So I'm a solar scientist, and I viewed the sun probably differently to a lot of people. Certainly before I started studying the sun, I viewed it as this separate object in the solar system that was quite unconnected to us here on the Earth. But now, after having studied it, I see the sun as an object that gives off lots of particles, something that we call the solar wind. And these are charged particles, and they flow out from the sun all the time, and it's a gusty wind. And it flows out to the edge of the solar system, 17 billion kilometers away.
And yeah, so I understand they ridiculed Eugene Parker in the 1950s when he first came up with that idea. Astronomers were saying, "What a stupid idea that is! A wind that blows from the sun." Yeah, right.
Yeah, that's right. And now it's such a fundamental thing for us. And it creates beautiful things like the comet's tails. It's the reason that cometary tails blow off and create these millions of kilometers long beautiful effects. But the interesting thing,
so they're like comet tails are like weather vanes, aren't they? That are being blown by the wind from the sun.
Yeah, that's right. And actually, one of the PhD students that I work with, is interested in using comet tails to investigate the wind being blown off from the sun, and he's wanting to work with amateur astronomers who are taking photos of the comets and then put all these images together and kind of get a map of how the solar wind how these particles from the sun, how it varies across the solar system, which is just such a fantastic
how
idea.
interesting. Yeah, it sounds
It's
great.
fascinating. You know, they say the best way to learn about anything is to write a book about it. So I found in this last year and a half just fascinating things I never knew about the sun. I'm just sorry that I didn't contact you, because you said something the other day to me that was fascinating. We know that for over a century now that the solar phenomena are essentially magnetically induced. But didn't you say something that these giant storms on the sun, these CMEs, are places where how did you put it? Where it's necessary for the sun's health, right?
Yeah, that's right. I study the magnetic fields of the sun's atmosphere. So these particles that blow off in form of the wind, if I can describe it that way, ultimately come from the sun's atmosphere. But there's also these very large magnetic fields there, and they too erupt into the solar system and form something called a coronal mass ejection. And for people that know me, I'm always talking about coronal mass ejections. But they are necessary for the sun. The sun creates a magnetic field deep inside the star, and it rises into the sun's atmosphere. And if it doesn't get ejected, then it would endlessly accumulate. So I see these coronal mass ejections as a valve for the magnetic field to escape the sun and prevent an endless accumulation. But, you know, the magnetic field goes somewhere. And I was really intrigued by the NASA news story last week, I think it was, about the discovery by the Voyager spacecraft, which are now at the edge of the bubble of hot gases and magnetic field created by the sun, the edge of the heliosphere that it's called, and how it's all bubbly at the edge of where these Voyager spacecraft are now. And I just thought, that was just fantastic, because that's where these bubbles of magnetic field in the form of coronal mass ejections end up, right at the edge of the solar system.
What a time to be alive, huh? What a time to be alive.
Oh, it's fantastic.
Now, are you involved at all in helioseismology?
I'm not, but I pay a lot of attention to it, because helioseismology is the only way in which we can study the interior of the sun.
Could you tell our listeners and viewers what that is?
Yeah, so it's a really nice technique that uses the fact that the sun rings like a bell, because it has sound waves bouncing around inside the star. And these sound waves, they're emotion, sound is emotion, and it causes the surface of the sun to move up and down. And we can actually measure these movements, which is incredible. So you look at the surface of the sun rising up and down and all the patterns that are created, and then you take those patterns and you can infer what's happening inside the sun. It's very mathematical, but incredible. They do it for the sun, but they also do it for other stars too. But
so is it a little bit the way earthquake experts here, seismologists, can infer what's below the Earth's surface because of the motions of our surface? So the same thing is done with the sun. Would you say that's accurate?
Yeah, absolutely, yeah. And we'd like to do it on the moon as well, actually. So a technique that can be used throughout the universe.
Oh, you brought up a good point, because didn't we find that the moon, when it's struck, rings like a bell for up to 2 hours?
Yeah, the moon has sound waves in it, and it's thought to have quakes, moon quakes. So it's one thing that before we maybe put humans on the moon, if we're ever able to do that might need to be studied. You might want to make sure you build your lunar base somewhere that's free from moonquakes. Yeah. So,
Now, a number of people are saying, I've noticed there's a difference here between Duncan, who optimistically was saying that we'll return to the moon someday, I'm sure we will, and Lucy, who's a little more, I would say, realistic perhaps, or maybe pessimistic, saying that if we ever do go back to the moon. But one of the stoppers is something that Lucy mentioned earlier, and that is those particles from the sun and radiation, which one of our women astronauts, Shannon Lucid, who spent more time in space than any other U.S. female astronaut anyway, really believes will be a stopper, that the amount of radiation. I've read a figure that on a 2-year Mars mission, the astronauts will get so much radiation that somewhere between 15 and 40% of their brains will be destroyed.
It is something that has to be considered, yeah.
Yeah, and even us smart people can't afford that.
Absolutely, no. I think I'd be out of the job if that happened to me. But
I'd be in an awful state.
particles that come from the sun, they're very small, they carry a charge, and they have a lot of energy. And they're constantly blowing out from the sun. But there are also other events, I mean, similar to the coronal mass ejections that I mentioned earlier, but other events called solar flares. So between the solar wind, coronal mass ejection, and solar flares, you get a lot of very, very high energy particles given into the solar system. And on the Earth, we're protected by the fact that we have a magnetic field. That's a really good barrier to these particles. But the moon is moving in and out of the Earth's magnetic field. And so I kind of see the solar system with magnetic eyes. So the sun has a magnetic field, the Earth has a magnetic field, and the moon is skimming in and out of the Earth's magnetic field. So sometimes on the lunar surface you're protected from that coming from the sun, but then when you move outside of it, you're not protected. And so the Apollo astronauts in particular, I think actually it turns out they were quite lucky to not have received big particle doses from the sun. They managed to not be on the lunar surface when some large solar flares happen.
Yeah, I understand that Apollo 17, if it had happened a month or so later, it would have been a different story.
Yeah,
Yes.
I read that they think that fatal doses of particles would have been received by the astronauts. These are small, high-energy particles that can penetrate the skin and give you radiation sickness. I mean, that could be a headache, or it could be low blood counts, but it could be cancer. It could be fatal.
I think some of them actually experience the particles that you're talking about, Lucy. I remember interviewing. This was for another program some time ago now. It was Charlie Duke again, an Apollo 16 astronaut, and he was talking about there was an experiment that was conducted while they were on the way to the moon. It was a very strange occurrence.
With the flashes?
Exactly, the scintillation inside the eyeballs, the flashes. And I got to look. There was a chap who was a researcher in Houston who I also interviewed, and he showed me very high-powered scanning electron microscope images, of very, very high-powered images of the helmets of the astronauts. And what was shocking is you could actually see where these very high-energy particles had burrowed through the helmets, and of course they would have ended up passing through the brain. And the astronauts were seeing these flashes.
I'm told that in the earlier flights, the early Apollos, the astronauts were seeing these things. And to our viewers and listeners, they would have appeared like streaking meteors suddenly across the field of view, and the astronauts reported seeing them about once a minute. At first they didn't say anything because, being old-time test pilots, I can tell you as a pilot myself, I'm not a test pilot, just a small airplane owner, that you never report anything that's wrong with you to any aviation physician.
Exactly.
You just know never to do that. So they didn't, but some of them were talking to each other, and they realized they were all seeing it, and Mission Control knew that, that these were mostly protons, high-speed protons from the sun, and, what could they say? Everybody knows this isn't good for you.
Yeah, it's interesting, isn't it? I think even inside I said that the Earth has this magnetic field and that it blocks the particles from the sun. And I kind of was truthful when I said that, because it blocks most of the particles coming from the sun, but some do make their way in, and then they get trapped in the Earth's magnetic field. And the particles then that are trapped also have high energy, and there are various processes that act on these particles and can increase their energy. So even once you're inside the Earth's magnetic field, you still feel the effects of high-energy particles. So even astronauts on the International Space Station will probably see the same effects as the Apollo astronauts, and are still at risk of cell damage because of these particles.
Is that what gives rise to the aurora, Lucy? The northern lights, the sort of shimmering lights we see in the sky at night, if we're in northern latitudes and southern latitudes. Is that the same sort of process?
Yeah, it's exactly the same thing. And they're the most beautiful manifestation of the fact that we have all these charged particles coming from the sun into the Earth's magnetic field, and then being energized, and then they are able to we don't fully understand the processes, but they can spiral down the Earth's magnetic field lines and hit the Earth's atmosphere. So
we're looking forward to that. We get them up here in upstate New York fairly often. I think it should be mentioned that a swarm of particles from the sun has its own magnetic field, and only if its field is opposite to ours. Of course, Earth has a field with north up, so only if the field is opposite will it transfer its energy to us. Otherwise, it'll be channeled harmlessly away from us. But the ACE instruments, the ACE spacecraft, located almost 1 million miles sunward of us, is the first place that can actually measure the magnetic polarity of the incoming particles. And so this doesn't give us a lot of warning, which is why you often hear that an aurora may happen if there's a CME or other great event on the sun, but half the time it doesn't, because the magnetic polarity has to be correct. And I also understand from I spent 3 years up in Alaska as a aurora lecturer, and we always went to the talk to the experts at the University of Alaska at Fairbanks. And one of the fascinating things up there is that if the energy really is transferred and the super high electricity is generated in the high upper atmosphere, then what essentially happens is the electricity itself, and just correct me if I'm wrong, Lucy, with this, causes, of course, electrons to be either stripped or excited to higher energy levels, mostly from oxygen, and then as they tumble down, they emit light at that 5577 angstrom wavelength, and there's that beautiful green of the aurora. And you'll notice that I'm saying angstroms, and I'm betraying my age here. People who are listening will know that nanometers are now essentially used, but when I studied this stuff in school, back when I was a kid, sonny boy, we only used angstroms, so I still think in angstroms.
I think in angstroms as well.
Do you really? Oh.
Yeah.
Hey, hooray.
So is it the case then that this excitation, it's sort of glowing like a neon sign? Is that how it works?
Yeah, very much so.
Yeah, that's how I think of it as well. And there's a switch that gets flicked on somewhere thousands of kilometers above our heads,
wow.
and makes them glow. And actually, there's a mission called Cluster, which is it's a European Space Agency mission. I mean, there are NASA missions as well that are up there orbiting the Earth right now, trying to understand how that switch gets flicked on to produce the aurora. It's something that humans have been looking at, ever since the dawn of mankind, and still we're trying to find out what's happening up there in our magnetic field.
Now, Lucy, since this is your field of expertise, and no doubt you're paid to go to places like that, it may not apply to you, but for listeners, and maybe even for Duncan, if you really want to see the aurora as the sun is now heating up toward its probable maximum in 2013, get to not just central Alaska, but the best place under the auroral oval, which is like a glowing donut surrounding the magnetic pole of Earth, is Chena Hot Springs, which is this marvelous place about 2 hours east of Fairbanks, right in smack in the middle of Alaska. And it's so dark there that they're right under the auroral oval, and about half of all nights they get amazing displays of the northern lights. If you want to get there cheaply, I'm going to again give a plug. I feel shameless about this because I don't make any money from it. Bob Berman, that's me, BobBermanTours.com. Go online and it'll show you. We're going back to that Chena Hot Spring next March for the aurora. But you really don't need me. You really get to that part of the world, and you'll have the absolute highest probability of seeing those rich greens and sometimes even deep cherry reds. Also, mostly from oxygen if it's high up, or nitrogen if it's low down from the aurora. I believe that's at a 6,400 angstrom, if I remember correctly, about the same wavelength as those red laser pointers.
Ah, okay.
Yeah. You sound like you've seen a lot of aurora.
Yes. We even get them here, as I say, in upstate New York. The ones there, though, are just so alive that they make the mountains of Alaska emerald. They make them green. You look around for 100 miles in all directions, and all the mountains are green. That's how bright the sky becomes. So.
Do they look, did they look better when you take a photograph of them? Because I've seen so many images on the internet now, and someone told me that your eye doesn't pick up the color as well as the camera does.
Usually that's true, but if an aurora is really intense, you definitely see the green, that pale green. As I say, it's 5577 angstroms, so it's right smack at the peak sensitivity of the eye. And I'm getting so excited here. I'm hearing like tons of feedback. Okay, that's a lot better. And there's the reds are a lot harder because, of course, the eye is much less sensitive to red light, especially at low light levels. But you'll sometimes get that deep cherry red as well, especially on the fringes. Up there, you're right underneath the auroral oval, as I said, so it often looks as if you're... The best way I could describe it is if you were a drunk that fell asleep on the floor and then awakened under some draperies that were somehow glowing. Let's say you were living next to a nuclear power plant and all the drapes were glowing in your house. And you're looking up right from below and seeing glowing draperies with the bottom fringes pink or red and the rest of it green. That's how it looks there, shimmering and slowly undulating and changing their appearance. So you very much do see the colors with the eye. Of course, the film makes it a little more.
That's a pretty vivid picture you paint there, Bob. It sounds amazing. I remember I saw it briefly once from my parents' home in the UK, but that was back in 1989, and I think it was a period, Lucy, when the sun was particularly active and had sent off, quite a lot of coronal mass ejections.
Oh, we had March 13th that year in '89. We had just an amazing CME, and we had auroras that went all the way down to Mexico and the Caribbean.
It wasn't very animated. It was more a sort of homogeneous sort of red glow, but it was still pretty spectacular. It's the only time I've ever seen the aurora, but it was pretty good. Bob, I've got a quick question for you. I'm just looking at the eclipse here, and that just on the on the website here, the SLU website, there's a snap pic button. What does that do?
Oh, that lets members of SLU, you click on that, and it's your picture, and it's just on your computer forever. You can also press some other buttons and send it to people, and it's just a great convenience. People can do that when we're looking at that supernova in the Whirlpool galaxy or anything.
So you can share pictures that way. Can you?
Yes. You capture them. So not only can you make the telescope point wherever you like on SLU, but then you can take and keep pictures and even like kind of drop it the way the way Buzz Aldrin would sometimes say, when I lived on the moon. That's what he'd actually say. He'd say, when I lived on the moon. And I always thought, come on, it was just a couple of days. You shouldn't say I lived on the moon. Like if I visited London for 2 days, would I say when I lived in London? But he used to say that. So you can take these pictures and you could say, yeah, I took that picture through the SLU telescope last night. And it would be perfectly true. By the way, I want to say that this event, this live lunar eclipse, is sponsored by Transformers: Dark of the Moon. That's the new Michael Bay film in cinemas from June 29th. The only way to see it is in 3D. Okay, we're here with our guests, Lucy Green, a wonderful solar astronomer in England, and with Duncan Kopp, another wonderful astronomer who's just done marvelous things. It's an honor to be with these guys. I'm Bob Berman, your host here. I'm on the other side of the world in the United States, and we're watching almost getting towards the end of the total part of the eclipse, but then following that, we're going to have the partial phases, which are also very cool. I'm up to talking about anything whatsoever. Anyone?
I'd love to hear from Lucy a little bit more about the sun. I think there was a coronal mass ejection quite recently. I saw some pictures from a satellite. I think it was called the Solar Dynamics Observatory.
Yeah.
And I hadn't seen absolutely mind-boggling images. They seemed fantastic.
Yeah, absolutely. I saw them as well. But they did come from Solar Dynamics Observatory. You're absolutely right. And I remember them getting circulated on the internet really, really rapidly as soon as the event happened. And that's a product of the data, of the images being freely available for anyone to have a look at. And there's a fabulous website called HelioViewer. And anyone, you don't have to be a solar scientist, any member of the public can go to the website and look at the images and make your own movie. And that's what people did. But yes, you're right, there was a coronal mass ejection that was so spectacular. I have to confess, I thought it was a fake. I thought people had photoshopped the images. So I had to go back and get the NASA data and have a look myself to convince myself it was real. Right. And the reason it was so spectacular was because there was so much material that was thrown up into the sun's atmosphere. So these coronal mass ejections are they're magnetic bubbles, but they also carry the gases of the sun's atmosphere with it, and they get ejected into the solar system. But this time, a lot of material also fell back onto the solar surface, and that's what created these beautiful images. Did you see them with all these dark structures?
Yes, it was incredible, because it seemed to me, of course, that the magnetism is invisible, which is always a bit of a bane for solar astronomers apparently, because you can't actually see those magnetic field lines. But as this material was falling back towards the sun, some of that plasma was getting trapped in the field lines and illuminating them. But then what was really spectacular was when the material hit the surface of the sun again. It was a bit like sort of bombs going off. There was little isolated brilliant points of light, and that was intriguing. In fact, I'm making a film at the moment for Nova and National Geographic, which is focusing on the sun. So I've spent with my editor quite a lot of time looking at these fantastic solar images now, and they're so engaging. And we sit there and sort of forget our job and marvel at these wonderful images. You always see something every time you look at them. There's something new to see. It's seems such an alien landscape, but in such high resolution now. It's wonderful.
That's right. I mean, I found myself this afternoon. I was using this HelioViewer software, and I found myself just sat looking at the movies over and over. Of actually a different event. I was looking at what the sun has been up to today, and I just caught this another eruption, another coronal mass ejection occurring, and I suddenly sort of caught myself just being mesmerised by these images, and I quite often do that, and I love the fact that the sun is so scientifically interesting, but also so aesthetically appealing as well, and we look at the sun with so many different parts of the spectrum now. So we use visible light, we use ultraviolet light, we use X-rays, and it looks different in each of these wavelength ranges, and then you can put them all together, you can combine the images, and yeah, they're absolutely spectacular. And as I said before, anyone can get hold of these movies as well, which is fantastic.
Isn't this great that we've got scientists here? We have professional astronomers, PhDs in astronomy that just love what they're doing, and they love the things they're seeing. This is not just dry and mathematical and physics equations. These are people who are in love with the things that they study. You're both very fortunate, I think.
Well, I think that's really. I mean, I have to put my hands up here. I can't profess to be an astronomer. I mean, that was quite some time ago now, 15 years ago or so. But it's what led me into my profession, which is now filmmaking, because there are so many amazing stories in science, and in particular astronomy, and the kind of images that we're able to see now are just totally. Well, they certainly excite me, and it's that wonderful process of detective work, for the first time, be it Hubble, or be it the Solar Dynamics Observatory, or another particular satellite. You're really get this feel it's a golden age. We're seeing these wonderful images, and it's lovely to be able to sort of weave stories around them of scientific discovery.
I think you're being too modest, Duncan. I know it's said that a person is an astronomer, professional astronomer, if half or more of their living comes from astronomy. There was Milton Humason. You might know his story. He was a mule driver at the old Mount Wilson Observatory, and he became a world-renowned astronomer without ever having any degrees. But if you make more than half your living from it, but in your case, Duncan, I would say that even if you were a waiter, you have a PhD in astronomy, you're an astronomer. There it is.
Well, it's kind of you to say so. It's always been a passion, that's for sure.
Meantime, we're watching the live lunar eclipse coverage presented by slew.com, and we're heading now towards the final, probably 7 minutes before the partial phases begin again. We have seen a normal eclipse. Normal is good in space because, the Mayans said the world's going to end. We want to make sure that they're wrong, and so far they are wrong. We have two distinguished astronomers, Lucy Green and Duncan Kopp, joining us here. I'm Bob Berman for the live coverage of the total lunar eclipse. The moon's just rising from places like England right now. Unfortunately, in case you were wondering, when it rises for people in North America, the eclipse will be over, and you'll be left with an ordinary full moon, the full moon of June. Earlier on, we talked about the different names for the full moon of June. It hardly matters. A little bit of the lore, the legend, the mythology, mental illness, births, all the things that people have believed about the full moon, and that's what we'll be left with here when the eclipse is over. We're very exciting. We can start seeing if you're hitting the Cypress spot in the telescope that's bringing to you from Cyprus. Maybe that shows more of the brighter light coming in on the left or east side of the moon, harbinger of the end of the eclipse. The image from Dubai has perhaps a little bit more of a red cast. I think a little bit more of an accurate cast to what you would see if you're actually observing the eclipse. We've been also talking about other things like sunlight on the moon and the role that sun is playing in our future hopes for returning to the moon and to other places in the universe. One of the problems is that the sun sends out these pesky particles and broken bits of atoms, protons, electrons, and especially the heavy stuff, protons. If I remember my high school science, protons I think are 1,860, is it, times heavier than electrons. So they pack a bit of a wallop, and if you're leaving Earth's magnetic field and heading outward, your HMO coverage may come to a stop. Your medical coverage may not cover you anymore because space is not good for you. But the moon is certainly good for us aesthetically, as we've been enjoying these amazing images. The right side of the moon is more fully in the middle of Earth's shadow. The left side of the moon now is about to emerge from Earth's shadow, and we've experienced syzygy. Do either of you play Scrabble?
Yes, I do. I love Scrabble.
I enjoy it too, actually, I have to say.
Then, if...
that sounds like a good word to remember, actually.
Yes, syzygy. Yes, syzygy.
What's the point score for that?
Well, you'd need more than the one Z that's or Z, as you would say, that's available in Scrabble. So you'd have to use a couple of blanks. I'm not sure it's worth it. You'd need, I think, 3 Ys, right? Syzygy. 3 Ys, 2 Zs. So I don't know if that's really worth it. But that means a 3-bodied lineup in space. Some people think that, the full moon, since the full moon is every month, is a lineup with the sun, the Earth, and the full moon. Why doesn't the moon go into Earth's shadow? And that's because the moon has a little 5-degree tilt that usually carries it above the Earth's shadow every time it's on full moon, or passes below our shadow. So it's kind of rare to go into the shadow, and rarer since, it's been a decade since this happened, centrally into the middle of the shadow the way it is now. So it's a unusual lunar eclipse. when we come back, we're going to have a station break soon, but when we come back, I'm hoping that both Lucy and Duncan can stay with us a while longer, and we'll be watching the transition to the partial part of the eclipse and some other cool stuff, too. We haven't even really gotten into some of the real oddities with the moon, like what's going on the far side. You know, when we first sent the spacecraft, nobody had ever known what the far side of the moon is. No human beings had ever been there till that first Russian spacecraft went there in 1959. We assumed the side that we see was similar to the far side, but for all we knew for sure, maybe the moon was just a half shell, and there were just 2x4s and scaffolding holding up a shell there, and there wasn't really even a far side. But everybody thought that the far side would look like the side that we see, but beep, wrong again, wrong as usual. Turns out the far side of the moon looks totally different. Looks like a different world than the side of the moon that we do see. And that's just one of the oddities of the moon. So when we come back, one of the things we're going to be talking about are the strange findings of the Apollo program and the things that make the moon so very different from the planet that we are living on. We're watching an eclipse of the moon. Let's see why the moon is so special, and maybe give some reasons why we might want to go back to it, or maybe not want to go back to the moon. So we're going to take a short station break, and when we come back after only a few seconds, we'll continue with this. Stay with us for continuing coverage of the live lunar eclipse.
Welcome to Slew Space Camera's live coverage of the total lunar eclipse, sponsored by Transformers, Dark of the Moon, the new Michael Bay film in cinemas from June 29th. The only way to see it is in 3D. Slew's live audio coverage of the total lunar eclipse is hosted by astronomer Bob Berman and powered by WSRadio.com, the worldwide leader in Internet talk.
Hey, we're back. I'm Bob Berman here in upstate New York, beautiful area in the mountains here, where the moon is not out. It's still daytime here. We have as my guests here two wonderful astronomers in the London area. One is Lucy Green, a solar expert, and the other is Duncan Kopp, who is trying to say he's not really an astronomer, even though he has a doctorate in astronomy. But that's because he's mostly been doing these marvelous things for the last few years, making movies that have sold 500,000 DVD copies and won Best Picture Award at Sundance, and just little things like that. And so we're back with them, and I want to say that this event is sponsored by Transformers, Dark of the Moon. That's the new Michael Bay film in cinemas from June 29th. The only way to see it is in 3D. Okay, we're back with the moon, and right now, the left side, the leftmost, and you can see it for yourself right now, the eastern edge of the moon is about to leave Earth's shadow, and we're going to see that shadow band marching across the moon. Now, the band is not a sharp line, simply because the thing that's casting the shadow, the sun, is not a point source. If the sun were a little kind of halogen light, a little tiny speck, then the Earth's edge would be a very, very sharp edge. But you know that if you look at your own shadow as cast on the sidewalk in front of you on a sunny day, you know that it has kind of a blurry edge, and that's simply because the sun has a diameter to it in the sky. It has a half-degree diameter, and the larger the source of light, and the more blurry the edge of the shadow will be. That's why fluorescent lights, those long tubes, cast totally, absolutely blurry shadows. So we're going to see the blurry edge shadow of the Earth cast onto the moon, and supplying one more proof of what the geometry is, and one more proof that Earth and the sun, it even tells you the size of the Earth and the sun. All of this just for observing this eclipse. Okay, guys, we're back. Hi.
Hello.
Hi.
So as we continue now in our final hour, Let's throw it up. What would either of you like to talk about?
Well, I was thinking that actually looking at the pictures coming through on the feed now, and we can see the sun visually, but tying into what we were talking about earlier, the moon is. Did I say the sun then or the moon? I may have said the sun, but the moon is in a special place at the moment, and it's actually inside the Earth's magnetosphere. So that always happens at full moon. It spends about 6 days inside the Earth's magnetic field, where, as we talked about earlier, there are all these charged particles. And so the moon, as a result of being in amongst these charged particles, should be negatively charged at the moment. How's that for a thought?
Well, this is fabulous stuff. This is absolutely wonderful, fabulous stuff. Now, when you say within our magnetic field, does that mean that it's fully blocked from the sun's solar wind, or does it mean that it's getting more stuff because our magnetic field is kind of accelerating stuff maybe from our magnetotail? What effect does this have, being partially in it? Is it a good thing or a bad thing for anyone on the moon at the moment?
Well, gosh, it can go either way. So it is not experiencing the solar wind flowing over it at the moment, but because the Earth's magnetic field traps charged particles, it's still getting, it's still sitting in a sea of charged particles, and so that can be a bad thing. And I was thinking, if we had astronauts going back to the moon, how would it be for them when the moon is sitting in the Earth's magnetic field like this and getting negatively charged up? I mean, will they have static discharges in their spacecraft, or will the dust on the lunar surface really stick to them? Because apparently none of the Apollo astronauts or the Apollo missions landed on the moon when it was inside the Earth's magnetic field. It was always
because that happens around full moon. It goes into our magnetotail. Is that correct?
Yeah, that's correct. Yeah, and it spends about 6 days inside. And during this time, it's moving through the high energy particles in the magnetotail.
Yes. That was deliberate because the planners always wanted each astronaut team to land on the moon about 2 days after local sunrise. They figured they didn't want the ground to be too hot. They did want to be able to see any obstructions, boulders, rocks, holes. So they wanted there to be some shadowing. Yeah. But they didn't want it to just be the day of local lunar sunrise, because then the shadows would be so long that the shadowing might have hidden dangers. So they figured about 2 days, 2 to 3 days after local sunrise was the best time. And because of that, none of the astronauts were there at full moon. Yeah, so you're quite right.
Yeah, and so that was probably a coincidence, I suppose. I mean, there were other reasons, like you say, those reasons for going at that point in time, but actually it probably, in hindsight, was an excellent choice for these other reasons as well, to do with the negative charge and the build-up on the moon.
All right, so let's talk about what's on the moon and how it differs from Earth, and why we might want to go back, or why in this era of budget shortages, maybe it's just as well that we don't go back to the moon, a place with no water and no air and nothing seemingly valuable. How do you two feel about it?
Well, you mentioned no water, but of course that's probably one of the most contentious issues about lunar geology.
That's true, at the poles anyway, yes.
Absolutely. Yes. One thing that perhaps, if we were to go back to the moon, one salient commodity there, if you like, would be the discovery of a lot of water that may reside underneath some of the craters at the poles. And the reason being is because there are these areas of the moon at the poles that are in perpetual darkness. If you imagine the sun being very, very low on the horizon at the poles, and you have a large crater there, or a large impact basin, you've excavated a lot of material, and if you were to climb down into that basin, into that crater, you wouldn't see the sun at all. And in fact, there are places at the poles where the sun hasn't shone for eons, and it's thought that perhaps there's, over a long period of time, water from comets and asteroids that's been delivered to the moon as these bodies strike the moon have made that water's made its way up to these areas and condensed, if you like, and become trapped within the lunar soil up there. So there's a lot of interest at the moment to see whether there is water ice up there. In fact, I think that's pretty much confirmed, but just how much there is up there and whether that could help colonies in the future should we want to go back to the moon.
Yes, this was a big change when the Apollo astronauts went there. The moon's rocks were all anhydrous. They seemed bone dry. Couldn't even squeeze water out of them chemically. But thanks to the U.S. Army's Clementine spacecraft finding first a little signature of hydrogen over the lunar craters and then subsequent missions, it really looks like there may be ice there in the poles. So, but the question is that enough? Here we have an airless world, high radiation, nothing valuable on the surface. I mean, we're looking at the moon now. We're watching the eclipse now as it's starting in its partial phases again. And what are we looking at? We're looking at mostly SiO2, silicon dioxide, sand. We all know that not worth going to the moon for sand. It's about 50% of the moon. What's the rest of it? About a quarter is magnesium oxide. Another maybe 12% is ferrous oxide. Another few percent is aluminum oxide. A lot of oxides. In other words, half the moon is oxygen. So if we want to think of what the moon is when we look up at it, just think of it as mostly oxygen, and the rest is kind of almost trace substances, except for silicon, magnesium, a little bit of iron. But boy, that's not anything worth going up there for. Should we spend the money and go back? It's sort of been answered since President Obama already canceled the return trip to the moon. Should we go there, or should we just concentrate on Mars?
Oh, I'd like to see people go back to the moon, I think. And actually, I was being reminded of a film that came out in 2009 called Moon. It's a British film. I don't know if you or the listeners saw it, but that was quite an inspiring film because it sets the idea, in my mind certainly, of going to the moon to mine helium. So on the Earth, this stuff isn't very abundant. But on the moon, because there's no atmosphere, the helium coming out from the sun in the solar wind can embed itself in the lunar surface.
You're talking about helium-3?
That's right, yes. Yeah, and it's a product that we use here on the Earth in particular for fusion studies. So
it wouldn't just be used for like breathing in and making your voice sound like munchkins.
That's how I use it.
Quite a long way to go for that, I think.
Actually, we use it in our spacecraft as well. You can cool things down with your liquid helium. But I don't know. I just thought it was a nice idea that, would it at some point be worth it? Can you recycle it enough on the Earth? Can you get enough for your needs? I mean, in the future, if fusion becomes a possibility, then maybe we'll need to go to the moon to get this stuff.
It's a very interesting point, and I think the film Moon actually is great. It's I've seen it. I saw it when it came out. It was directed by a chap called Duncan Jones. It was his first film, and it's Lucy, as you were saying, it's the plot is basically Lunar Industries employ a particular person who's up there and mining, and he goes through all manner of effects, basically. But very interesting sci-fi film. But there is a thread of science in that film, and I know that one of the last men on the moon, Harrison Schmitt, who flew on Apollo 17 in 72, he's a very big advocate for helium-3 and has a lot of his professional academic career. He was the only geologist trained geologist to visit the moon. Or I should say a geologist before becoming an astronaut. And it's an area that he's particularly interested in. And I think it all comes down to one thing. It comes down to a point where it's profitable to be able to do this. And, of course, there was a time not that long ago when only the elite had enough money to get on to a comet, and I'm talking about the plane, and fly across continents. Of course, now that's commonplace. And I think as space exploration continues, and if we're able to find a safe and reliable and inexpensive way to get out and get up there, then suddenly the margins with regards to that kind of venture start to look profitable. You start to look doable. That's why I think it's only a matter of time. I think when that time is, nobody quite can put their finger on it, but I think it'll just happen. It'll just precipitate, and all of a sudden it'll be commonplace.
Now, we know that helium, helium-3 is an isotope. It has a different number of neutrons than normal helium, but it can be made here on Earth. And from what I understand, I'm just going to give I'm going to play devil's advocate for a moment with you, Duncan. Right now, fusion is not. We've found no way to make that work as a power source. People, Lord knows, have been trying. And if it's not a power source, and given the fact that we could create helium-3 on Earth, I wonder if the numbers would still add up, given how expensive it is to the moon. Certainly the water would change everything, right? If there's ice.
No, you're absolutely right, and you're making a very valid point, and I think it's echoing the point that I'm making. What's really going to get people back to the moon is obviously exploration. I think that's something that's inbuilt in humanity. But what really seems to drive things is economics. And it's interesting because I think shortly we'll see perhaps the first fare-paying passengers who take a suborbital trip into space and make a half-hour journey into orbit, and that will just change the way that we view space. No longer is it purely for exploration, but also it crosses a boundary. It suddenly becomes something, okay, it's still going to be incredibly expensive to buy one of those tickets, but you can buy a ticket. And it's not as if it hasn't happened already. I mean, we've had space tourists, people who have actually paid to travel into orbit. And I just think it seems logical to me. I don't know when, and I don't know quite what will sort of precipitate it, but I can't see why it wouldn't happen.
Yeah, I agree with you there. And I was thinking while you were talking that the way even space science and the research arena is done is changing. So there's going to be more links with industry and more private companies being used to get humans into space now. And so if the technology is being developed for that purpose, then there surely will be more spin-offs in the space tourism area.
I wonder, Lucy, if that's not the catalyst. That's what, as we move from as it moves into the private sector, you may well find that before we know it, there's a whole plethora of private space industries doing things on a small scale, but still doing things, that both from a research point of view, but also from perhaps something more exciting. Well, I say exciting, but more sort of prevalent to people who want to travel into space.
And I wonder, since we're watching the moon now, I'm Bob Berman here with our guests Lucy Green and Duncan Kopp. As we're watching the partial phases, the moon is going in reverse now. The red color is disappearing. We're back to sunlight ever growing on the eastern or leftmost part of the moon as we watch the outline of Earth's shadow. That's what we're seeing, our own planet shadow, so that people on the eastern part of Earth, if they could stretch their hands up, people who are experiencing sunset right now, if they could reach up in towards the sky, you could see their shadow right on the edge of the moon on the left side there, waving to you on the left side of the moon. If only they had giant hands like I do. We're talking about going possibly to the moon. I wonder if we ever set up residences on the moon, whether it would be the neighborhoods. It would depend upon where on the moon. For example, the poles, as Duncan just pointed out, is places where there'd be ice and hence water. That would obviously be more valuable properties and suffer, unfortunately, higher taxes. Places along the limb of the moon would also be places where the Earth, as seen from the moon, would be hovering just above the horizon. That would be desirable as well. The far side of the moon would have no Earth in the sky. That's a minus. Those would obviously be the poorer homes. That would be the tract housing. That would be the ghettos on the moon. No Earth in the sky. Places right in the center of the moon, the Earth would always be straight up. See, from the moon, although the sun crosses the sky in a 2-week period, the Earth is always in the same spot, never deviates. So once you have bought your property, signed the lease, wherever the Earth is in the sky, that's where it's always going to be. Sort of the equivalent of Polaris, the North Star for us here on Earth, where from your home, wherever the North Star is, it's always going to be in that same spot. So different strata, different property values, depending upon where on the moon you want to live. I think that's probable for the future.
So where would the best place be for astronomy if you?
Well, they say the best place might be on the far end, because then you wouldn't get any interference from Earth. But then again, you'd be out of touch with Earth-based telescopes. I think any part of the Earth, the moon, would be good. Of course, you'd want to be near the poles because you want that yummy ice and water. You definitely want water. You get thirsty otherwise. And I think it was figured out that that water cost $10,000 a gallon to haul to the moon for the Apollo astronauts. So you can't have that. We're counting on there being copious ice in those dark, never see the sun craters, those vampire layers that exist on the south and the north side of the moon. I want to ask both of you, for Scrabble, do either of you memorize the 2-letter words?
We always, well, I don't know if this is cheating, but we always look at the sheet, I'm afraid.
Oh, no. Got to memorize those 2-letter words, A-A, A-E, A-I. That's the important thing. Let's talk about future eclipses in this kind of desultory rambling here at SLU. One or two thank yous, though. I want to thank Google for their support of this. I want to thank, of course, the new movie Transformers coming up. The event is sponsored by Transformers Dark of the Moon, the new Michael Bay film, in cinemas from June 29th. See it in 3D. And most of all, I want to thank SLOOH, S-L-O-O-H, SLOOH.com. You're probably seeing this at eclipse.slooh.com, but just go on slooh.com or hit that button, become a member, and you'll be seeing live astronomy. Not just seeing, you'll be controlling it. You'll be making the telescopes turn to wherever you want. You can do serious astronomy with that. Take your pictures of it, see the Crab Nebula, the Whirlpool Galaxy, watch Jupiter spin. Unbelievable. Definitely do that as well. I also want to thank, not that they're leaving right now, but I want to thank Lucy Green for taking the trouble to join us from London. I want to thank Duncan Kopp. I'm not going to plug any of this thing. We've been plugging his stuff all show long, but definitely look Google him, and you'll see some of the things he's doing. Me, Bob Berman, I guess the only thing I'd be plugging is my new book, The Sun's Heartbeat, coming out next month from Little Brown, or BobBermanTours.com. It's a way to see the Northern Lights next March, or the total eclipse of the sun in Alaska next November. BobBermanTours.com. And that, I promise, is the last of the plugs. Now all that shameless stuff is over, and we'll talk a little bit more about the moon and about coming eclipses as well. If you like this, we're going to have another lunar eclipse this December 10th. That time the moon will not go centrally into Earth's shadow, and those in North America, in Canada and the United States, will be able to see it. There's actually not a lot of total eclipses between now and, let's say, 2021. In the next 10 years, after this, there are none next year. None. There are none in 2013. None. In 2014, there will be 2 total eclipses. In 2015, there will be 2 total eclipses, visible in various parts of the world. Then none in 2016, none in 2017. In 2018, there will be 2. 2019, there will be 1, and none in 2020. So there's not a lot, really. What is that? 2, 4, 6, 7 in the next 10 years, and only half of those or so will be visible wherever you are. And wherever you happen to be located, try for that wonderful transit of Venus that's coming up next year, when the planet Venus is going to cross the face of the sun. Now, that only happens on average twice a century. The events come in pairs, 8 years apart. And so if you miss this one, you're going to have to wait for the 22nd century to see Venus cross the face of the sun. So that's a major thing. I'd say in terms of the greatest celestial events, we're looking at a live lunar eclipse now, of course. The greatest celestial events, without having a big fancy telescope, are probably a total eclipse of the sun. Everyone who's seen them, and both of these guys that we have on the phone, Lucy here, who saw a great one, and Duncan, who says he saw it from England through.
You don't believe me, do you?
If so, he was the only one who saw that eclipse on August 11th of 1999. You don't look for eclipses from England. You just don't do it. Sorry. But he saw it a little bit, but I urge everyone to get to a total eclipse of the sun. I'm going to give you an idea of how spectacular that is. During maybe 8 years ago, during one of our Northern Lights tours up in Alaska, central Alaska, we had about 35 people in the last one. I did that for 3 years. And we had just come indoors after seeing the most amazing all-sky, swirling, brilliant auroras. This is the best I'd ever seen. We always hold those in March, by the way, because you definitely want a big chunk of night. People go to Alaska in June, July, August and take a cruise, and then they come back and they say, I didn't see any northern lights. Well, of course you didn't. There was no night, was there? So March is a good month because Earth is sideways to the sun. The worst of the Alaskan winter is over. It's just a perfect month. That's when we always do our tours to see them. People just come in, and I asked everybody, because I figured these people are wealthy enough to do, a lot of them were Japanese, and they were wealthy enough to be the kind of people that went on nature tours. So I said, how many of you have seen a total eclipse of the sun, have gone on a pilgrimage to see one? And sure enough, 25 of the people raised their hand. And I said, then allow me to ask you a question. Which did you find more spectacular? The aurora that you just saw a few minutes ago, or the total eclipse of the sun? And wouldn't you know that all but one picked the total eclipse of the sun? So that's how powerful a totality is of the sun. We've just seen a live lunar eclipse. That's certainly lovely. But a total eclipse of the sun is life-changing, makes people weep, knocks people backwards. It's just, and cannot be well captured on a computer screen or through photography. You just have to see it. So let me mention which of those are coming up. I just mentioned lunar eclipses. We're going to have, of course, the Australian eclipse in Cairns next year, 2012, November 13th. Then there's going to be a bunch of miserable ones. In November of 2013, there'll be a very, very short and cloudy one in a cloudy time of year right off Africa. We can kind of forget that. On March 20th, 2015, that's the equinox of 2015, a totality will start north of where you guys are in England. That is in that frozen ocean to your north of Scotland. And then it will continue on up to the North Pole at a cloudy time of year in the North Atlantic. In 2016, there'll be a total solar eclipse on March 9th. That'll be Indonesia. That's a possible one. And finally, on 2017, August 21st, will be the first totality to cross the United States in 38 years. We've had an amazingly long eclipse drought here in America. And that's a totality that will go from the Pacific Northwest through Jackson, Wyoming, just south of Yellowstone Park and the Grand Tetons, slash across America, go over Nashville, and finally the path of the moon's shadow will exit in the Carolinas. That's a long, long-awaited, precious eclipse, August 21st, 2017. After that, there'll be two in southern South America, oddly enough, 1 year apart, 2019 and 2020, visible only from Chile and Argentina, other than the extreme South Pacific Ocean. And finally, in 2024, April 8th, for stay-at-homers in the United States, an eclipse that will sweep up from Mexico, across Texas, Cleveland, Ohio, Buffalo, New York. There's a reason to go to Buffalo, New York. My wife's alma mater is in Buffalo, so I can't say anything bad about it. Rochester, and then Burlington, New Hampshire, Vermont, which is a lovely place, really, Burlington, Vermont. And then finally, it will end up by startling the moose in extreme northern New England. That's 2024. So here in the North America, we're going to actually have two. That's odd, in just 7 years, in 2017 and 2024. So that's the coming solar eclipses. I already told you about the coming lunar eclipses. And while I've been doing that, Earth's shadow has been creeping across the moon. The red is gone, and we now see the sunlight shining fully on the left side of the moon, where we see the outline of Earth, a much larger Earth than moon. You can see that the radius of curvature of the Earth shadow is very different from the radius of curvature of the moon itself in space, the inky moon in space. While I've been blabbing, I know you guys have been thinking of something that you want to say. Go ahead, either of you, just jump in.
Well, I was thinking about seeing eclipses from space, actually, while you were talking about that, and how useful they are for scientific research. So I was thinking there's one spacecraft in particular that I use. It's called Hinode. It's actually a Japanese solar observatory, and we have a telescope. There's a British telescope on board this Japanese spacecraft. And we had a solar eclipse that we saw from our spacecraft back at the start of June. So the moon moved in front of the sun. And, obviously it's a solar observatory, so people would probably be thinking, well, what use is that for you? But actually, we use it to calibrate our instruments. So during these times, we can't take any scientific observations, but we can see how dark the moon appears, and we can study how much light is scattered around our telescopes, and then use that to calibrate them and subtract that off of the images of the sun that we do get the rest of the time.
Lovely. Duncan?
Well, I was thinking about Lucy's research and some of the images that I've been looking at. And there's a spacecraft, I think, called SOHO, and that has an instrument on board where you create a little artificial eclipse, which allows you to see these fantastic coronal mass ejections, this huge billion tons of plasma that gets blasted off the surface of the sun. And of course the sun's surface, the photosphere, is incredibly bright, it's blindingly bright, but to be able to see this wispy, ghostly mass of particles that get sprayed out from the sun, it's always a very engaging image to me, how this instrument blocks out, eclipses artificially the sun's surface so that you can see these coronal mass ejections. That's always a really intriguing instrument, and you can actually see the sun move against the background stars, and it sort of bellows and sneezes and burps. These huge masses of material come flooding out, and I think it was then that I really thought our sun is actually a pretty violent star. I mean, this thing's got a temper, it's got a Jekyll and Hyde personality.
Yeah, it absolutely has. Yeah, and that's it. You need to go into space and use these telescopes to be able to see the true nature of the sun. I mean, before I started studying it, I thought it was this yellow disk in the sky and that it didn't get up to very much. But you go into space and suddenly all this activity is revealed to you. And these coronal mass ejections, they happen all the time. The sun has an activity cycle. So at the minimum of activity, you might get 1 or 2 coronal mass ejections a day. But at maximum, you might get 5 every single day. And they can go in any direction. So some will just find their way out all the way through the planets and they'll miss everything. But some will come over the Earth, or over other planets in the solar system. And then the magnetic field of the coronal mass ejections and the hot gases, the plasma, interacts with the magnetic field and the atmosphere also of the planets that they move across.
I love this stuff. Listen, Lucy just said something very interesting when she was talking about before she got into astronomy, she thought of the sun as this yellow thing in the sky. And it's true, if you let children use crayons to draw pictures of the sun, they'll always use the yellow crayon. Some textbooks even call the sun a yellow star. Our spectral type is GO or G1, depending upon who's saying it, but that's always called a yellow star. And yet, astronauts in space insist that our sun is as white as snow, truly as white as snow. So here's something I thought I'd share with our listeners, a very, very cool thing. The sky is blue because since the sun sends us all the primary colors of light, all the colors of the rainbow, all the colors of the spectrum, but the ones that are important are red, green, and blue, because the combination of those three produce all the colors. Those are the primary colors of light. The blue, being the shortest wavelength of all of them, gets scattered by molecules in the air. They're just the right size to bounce these wavelengths around. Actually, it bounces the violet around even more, but since our eyes are so insensitive to violet light at the edge of the spectrum, we really perceive the next most prevalent color in the sky, which is the blue. We see the sky as blue, but the point is that since this blue light from the sun has been scattered, the remaining two colors that come from the sun are primarily red and green. We didn't get the blue sky for free. That was blue light that was robbed from the incoming sunlight. So the rest of the sun's image has a overabundance of red and green light, when combined, look yellow. So what I'm saying is that the apparent yellow sun is because of the blue sky, and we wouldn't have the blue sky without a yellow sun. The two of them absolutely go together, blue sky, yellow sun. But here's what's really cool. If you want to see the true color of our nearest star, of the sun, the same way that the astronauts do, there is a way to recombine those wavelengths, and that is a snowy field or anything that's pure white, even a white sheet, on a clear sunny day, a cloudless day. In the winter, if you're seeing a snowy field, what's happening is that the sunlight, the yellowish sunlight, is hitting the field, but so are the blue sky. The blue from the blue sky is also hitting the field. So those two colors recombine, letting us see the same thing that astronauts would see. So snow on a clear day is the true color of the sun that you would see if you were in space from astronauts, and if our atmosphere weren't playing its shenanigans and giving us the blue sky. Isn't that cool?
Yeah, it's interesting. Yeah, I hadn't thought of that.
And I want to talk now about, as we watch we're in our final 25 minutes of the eclipse, and we watch Earth's shadow. Notice now that the edge of Earth's shadow, you can see that it's not a very sharp line. In fact, if we were using high magnification, you'd see that even more clearly. But it has some width to it, and that blurriness, that edge, very reminiscent, again, of the shadow that you would cast from the sun when you walk down the street. It's not a sharp edge. Well, sharper where your feet cast the shadow, and quite blurry where your head casts the shadow, especially if you've been drinking the night before. But you can really
see that on the Cypress feed. Actually, it's very clear.
Yes, and so this is really giving us an absolute information about how large the sun's disk must be in order to produce a blurry-edged shadow. And as it's uncovering one after another of the sites of the various Apollo astronaut landing locations, let's talk about something that Duncan mentioned earlier, which is stuff that was left behind on the moon. He mentioned footprints in the sand, but there were also gold-plated plaques left on the lunar surface by all the Apollo crews, and they had a nice sentiment to them. You know, we came in peace for all mankind. But at the insistence of the White House at the time, the then president, Nixon, made sure that his name and his signature appeared prominently on each one. So since these are going to last for at least 500 million years, these gold-plated plaques on the moon, should aliens ever stumble into our corner of the universe, even 500 million years from now, when the human race is gone, all traces of it are gone, or else we've evolved into something would be unrecognizable from today, those plaques and maybe even their inscriptions will still be legible. And if those extraterrestrials somehow could figure out what those recurring letters meant and knew that it was a human name, they might wonder what glorious achievement caused this single person to be chosen for immortalization beyond the human race itself. And, of course, that name on the moon at every one of the 6 Apollo sites that will survive the human race itself is Richard M. Nixon. In case you wondered, I wish that they'd included one of his famous quotes like, "I am not a crook." I wish they had put that on the plaque. But just in case you wonder what is there on the moon that we've been watching now during these 3.5 hours of eclipse coverage, what will endure beyond the human race, there it is, the name Richard M. Nixon on the moon.
Because I hadn't thought of that. Of course, he's got 6 signatures on the moon, and the actual astronauts only have 1 each. So
that's right.
Hadn't thought of that. But of course, there's a lot of other space hardware that was left up there by the Apollo astronauts. There are 3 of the lunar rovers, and it'd be interesting to go back and have a look at those. But also, there's a lot of Russian hardware up there. The Russians had very successful unmanned missions to the moon.
Yeah, they even brought back a few ounces, didn't they, of moon stuff with no risk at all to
absolutely.
Human
They
life.
did a sample return and very successfully got material back. And of course, that was really the start of the whole space race. The Russians and the Americans wanting to reach for the higher ground, which at that period of time was the moon. It was something that you could look up at and sort of say, well, look, if we get there first, that's a pretty big psychological thing. And we were talking a little bit about Kennedy way back when, at the beginning of the show, and of course he was running scared at the time, because at the very beginning of the space race, we're talking sort of early 1960s, the Russians trumped every single move they had.
Everything, yes.
First satellite, first astronaut,
first 2-man crew, first woman, everything.
First spacewalk, and so Kennedy called in his advisors and say, well, look, folks, what do we do? What is it that we can realistically achieve and huddle together? Well, let's shoot for the moon, and of course the rest is history.
That's right, because they quite properly pointed out that with the moon you couldn't just kind of modify your existing rocket. You'd have to start from scratch. You'd have to design a new rocket, and we'd be more or less on par with the Russians for that one. And, quite properly so. We should also mention the second landing on the moon, Apollo 12, whose goal was to land near the old Surveyor spacecraft, and they successfully landed very close to it, just as I recall, just at most a couple of hundred yards from it. And when they snipped off material, they wanted to see how this stuff fared after having been in the moon's airless environment, I think for 2.5 years, in those broiling temperatures, 250 degrees by day, minus 250 by night, no air. And when it was examined back in the lab, it was found to have a living germ on it, a streptococcus, that was still alive, that had contaminated the craft, obviously, before it was sent there, and was still alive. And so if you've ever wondered why it's so hard to get rid of a strep throat, that gives you a little clue.
Yeah, that's quite an interesting story. I still haven't got to the bottom as to whether they actually proved that it lived or whether it was contaminated on the way back. Hey, if it's the case that it lived, that's pretty incredible.
That's right. It was actually in a Vidicom. It was a camera. It was
And they wanted to cut the camera off specifically. It was one of the parts they wanted to bring back. But
right.
you were talking there about, that was an amazing achievement. We're talking about the second lunar landing, and it was a pretty pinpoint lunar landing. They landed not more than a couple hundred meters away from Surveyor 3, and to be able to do that back then was amazing. You've got to remember, and I know it's been said so many times before, but your cell phone, mobile phone, has far more computing power. My dishwasher probably has more computing power than the lunar module. And talking to some of the astronauts, it was really interesting to hear their perspective on that, because of course they had LED a console, and that was a total revolution to them. Absolutely amazing to be able to have this illuminated display to help them. And so much hard work went into doing that, and just how they stored memory in those days. It was a technique called a rope memory, a very, very primitive, very simple design to begin with, and all the technological challenges that they had to overcome. I remember one lovely story that a Saturn V rocket engineer told me when I was making the Discovery series moon machines for Discovery. They had a problem in the massive engine that sits at the very bottom of the Saturn V, this huge bell. It was called the F1 engine, and it had something called combustion instability. And basically, to you and I, it simply meant the thing kept blowing up. They couldn't rectify this problem. And of course, you want to say, well, surely you could just run some computer analysis. He told me we made that engine with a slide rule. We didn't have computers in those days, So and there's suddenly a gaping chasm between the world that you've been brought up in and the world that they lived in, and they got They had, I think it was 13 Saturn V launches, including the Skylab missions. Every one a success.
Was successful. And of course, the Saturn V is for those of us who are geeky enough to, or have memories enough to remember the program, we love the missions to the moon, but it was the Saturn V that got us there. Never has there been a rocket like that with 6 million pounds, 30 stories tall, and that first engine consisting of 5 F1 engines, the most powerful engines ever made. Duncan just mentioned the F1. Well, that single engine, of which, again, there were 5, was more powerful than any entire rocket that had ever existed. It burned fuel. You know what it burned? Ordinary, smelly kerosene. Kerosene. Same kerosene a lot of people use for home heating, mixed with liquid oxygen, and it lived. Each of those engines lived for only 2 minutes and 40 seconds before that whole first stage fell into the ocean as junk. And so what an accomplishment. And then the second engine was the second stage was a single F1 engine. What a thing to have done. You can hear the reverence in Duncan's voice when he talks about this, having made these movies about it and spoken to the engineers, and who could conceive of this? I know that at first the Saturn V rockets would rattle themselves to bits. They'd burn. How do you keep them from melting? So eventually they had all the cold liquid oxygen circulating around each of those engines so that they'd serve a dual role, cooling and also warming up the liquid oxygen. And I know that you couldn't rely on just a gravity feed. You had to feed these 5 engines, and each one of them burned 3,000 pounds of fuel per second. 3,000 pounds per second for each one of the F1 engines. So how do you get all that fuel into it? Well, you need a fuel pump. The fuel pump on the Saturn V rocket. See, I know these things still in my head. That's how impressed I am with them. The Saturn V rocket's fuel pump was 65,000 horsepower. Most of us have cars with maybe 100, 150 horsepower engines. This was 65,000 horsepower for the fuel pump for just that first stage.
It's interesting that we'll be going back more to the design of the Saturn back into space.
If they do it, remember the Ares rocket that was supposed to be sort of a Saturn V analog has been scrapped.
Yeah. But moving away from something that will have wings, like the shuttle, to having something that's more similar to the previous design, and minimizing then the risks of damage to the overall shell.
We have to be careful with this, because there is now and I've forgotten the name of the project, but it has been approved. It'll cost almost $1 billion, a U.S. Launch to an asteroid. And it's going to hopefully chip away a little piece of the asteroid and bring it back to the tune of $1 billion. Now, part of me, just like you, I'm enough of an astronomy person all my life. This is what's given me my living all my life. So, of course, I love the idea of it. But on the other hand, when you think of here in the United States, each family was had to cough up $3,000-4,000 per person in the United States, $3,000 or $4,000 per person on average, taxed, so we could get little pieces of one particular asteroid back. And I know what the reasons for it. Yes, it's nice to have a primordial chunk of asteroid. On the other hand, a part of me says, well, every meteorite is an asteroid, every single one, because comet debris doesn't survive its passage through the atmosphere. We're already getting asteroid chunks being delivered to us for free. How important really is it to do these, to pay that much, $1 billion for such a mission? So my long-winded point here is merely that we may in the future years have to be a little bit more frugal, a little bit more careful what we make people cough up, especially in an age where there is hunger and poverty and need for education and that kind of thing. It's always been an argument against space travel, and I've always taken the side in favor of spacecraft and even manned missions, but I don't know, there's a balancing act, don't you think?
Yeah.
I agree.
Yeah, and we can do more and more with robotic developments as well. So sending out small fleets of robots across the solar system may well be where we go next.
Yes, exactly. I mean, look at your sun stuff. Between SDO and Stereo and Trace and Soho and even in the old days, Ulysses and Pose and Goes and man, those were all robotic, and one was better than the next.
Absolutely, and I think you only have to look at the success of those really well-managed projects and the amount of data that's being returned. I think, Lucy, again, it's a statistic that I was reading, something like 2 terabytes, or just under 2 terabytes of data is sent back from the Solar Dynamics Observatory, this spacecraft that's now keeping a sort of 24/7 watch on the sun. I mean, that's a phenomenal amount of information. And again, it's an indication of how we're progressing and how much more we can do now for hopefully a little less. But there's always a statistic that sticks in my mind, and I'm probably going to quote this incorrectly, but I think I read somewhere that the Voyager missions, which were decade-long missions, which really gave us our first views of the gaseous giants, Jupiter, Saturn, Uranus, and Neptune, those missions may appear expensive on paper, but I think it was a fraction of the amount of money that the United States spends on pet food or something like that. When you put it into that context, it's worth thinking about what they add to human society generally, and I think it's worth putting that in context. But I think
you've just chosen among the very best missions. Who would ever argue with those various solar spacecraft, or Voyager, or Cassini, or Galileo probes?
Well, my point is I think a lot of people would. Before they fly, a lot of people would. I mean, I know that the Mars rovers cost, about the same as a Hollywood blockbuster. But a Hollywood blockbuster comes and goes, and that's great entertainment. I think Spirit and Opportunity gave us over half a decade of roving around the surface of another planet, which
Yes,
I think,
priceless.
I think it's equally, if not more so, inspiring. And I think there really is a case, perhaps slightly more for what Lucy was advocating with regards to unmanned missions. I think that's a very, very important area of exploration, which perhaps we can justify a little more.
Let's talk a little bit about the one of the other objections that I know that both of you are going to be on my side. As you know, many of the missions use plutonium as a power source, RTGs, radioisotope thermoelectric generators, which very efficiently generate electricity for years, actually even decades to come. The Voyagers are still working, and they're using the RTGs. Cassini had, I think, 3 RTGs with over 90 pounds of plutonium, and people are a little wary of that, launching things with plutonium. Do you think that the risks are very small, as I do?
Well,
Anyone?
God, yeah, I mean, getting things into space is a risky business. The launch is a risky time. And actually, I was thinking the missions that we've sent to Mars, I mean, we don't need to use radioactive sources there, but, I think there's like a 40% success rate, but that's considering the whole mission from,
And Mars has been a bad luck planet, let's face it.
It has, yeah. But I think at the moment, we don't have a lot of choice. If we want to explore the outer solar system in particular on timescales that we can do our research projects, then I think at the moment we have to be using radioactive sources, which, I mean, these are then big missions, they're very expensive missions, but it is encouraging that there are other technologies being developed. So, for example, ion drives that will take spacecraft out to large distances and eventually get up to high speeds. But this takes a lot of time. So, engineers and scientists are exploring other ways, but it's still being developed, that technology.
Oh, I love the RTGs myself. We're in the final 4 or 5 minutes of our program. Well, let's turn back to the moon for a moment as we see Earth's shadow now on the extreme right side of the moon, the western side of the moon. It doesn't change. The radius of curvature stays the same because that's our shadow, tapering like a chopstick from Earth's original almost 8,000 miles in diameter, and smaller at the moon. It's only a quarter of the way toward vanishing at a point. So we see it very clearly. There is the shadow of our planet Earth. The rest of the moon has emerged from the shadow just beautifully. And I want to thank the tech people who have traveled to these places, Dubai and Cyprus, for slew.com, which has made this possible. I certainly want to thank Google and Noel Gorelick at Google. He was the champion at Google for all of this, making this possible. We've already thanked Paramount Pictures, and also before we go off, I certainly want to thank our guests here, Lucy Green, who's just been a pleasure as we've spoken, particularly about her area of expertise, which is solar astronomy, and then also Duncan Kopp, whose many projects, too many to even list. I would suggest just Googling them and seeing what he's up to. That business about the Holtz, the planets, in HD with accompaniment of stunning images is just a fascinating thing to me. I'm Bob Berman with Astronomy Magazine. I'm also the astronomy editor of the Old Farmer's Almanac that goes back to the days of Ben Franklin. So with SLEW, which is a space camera that's always watching the heavens, every 5 minutes looks at a new celestial object, this was a natural to put this together. And nonetheless, there's a lot of technical expertise and so many possible glitches to this seemingly simple enterprise of catching a live lunar eclipse from a different part of the world. Even though we're going to sign off in only about 2 minutes, the eclipse will continue for just a couple of minutes beyond that as the moon scurries out of Earth's shadow. You can really see that, even though you can only see a little tiny section of the radius of curvature of Earth's shadow, it's very easy to create in your mind, looking at the screen, the size of Earth's shadow that it must be. And even though we can't see our planet in space because we're on it, somehow, looking at our shadow in space, it's the only time we can, because our shadow doesn't reach any planets. The only natural celestial object that our shadow can reach is the moon. Somehow this conveys a feeling of, I don't know, an awesome feeling of the clockwork motions of the solar system. And, I think it's kind of awesome. Any quick last thoughts, Lucy and Duncan?
Just to say, it's been a pleasure to experience the eclipse with you. It's been fantastic.
Yep, same here. It's been an absolute blast, and I've loved watching it from start to finish. It's been fantastic.
Yeah, terrific stuff.
Well then, we actually did it. We actually pulled this off, and there will be future eclipses and future celestial events, and I hope I have the honor and pleasure of being with these great astronomers again in the future. For SLU, for Google, this is Bob Berman wishing you a good night.